What's going on YouTube? We're back with another day practicing math live, and we are finally back to the one and only Serge Lang Basic Mathematics. This is the book that a lot of people are subscribing to me for and actually want to see me work. So we're going to be working on this book this week. But really, more broadly, we're going to be studying foundations. So a new structure is emerging in my live streams at the moment. For a while, I've been doing sprints of a sort, where it used to always be linear algebra, and I would sprint through the entire book and then reset, or I'd sprint through part of the book, reset, sprint, get a little bit further into the book, reset, sprint, get even further, and then at some point in linear algebra, I started covering the full book, and I felt pretty good that, okay, I remember linear algebra now. Like, I think I have a good grasp of linear algebra 1, like first semester linear algebra. So then we started adding other books. We started adding calculus and representation theory. And then we started adding this brand new series in basic math. And so this is now, like, a structure keeps emerging in this stream. And over time, more and more structure is being built into the main series of this book as well. So I want to insist on that because I keep getting comments from people that say that they're very confused by the structure, that there's not enough structure in the main series. I promise that I think about this a lot, and there is structure. It may not be very clear yet what it is. And it's partly because I've thought a lot more about the structure of the stream than of the main series. But in any case, structure that's forming here. For a while, I've been thinking week 1 is high school, middle school. Week 2 is undergraduate math, like college math, and then week 3 is graduate school math. That's still primarily true, but now another level of structure is foundations, number theory, and then abstract algebra. So week 1 is foundations, fundamentals. You need to be good at your arithmetic. You need to be good at your basic algebra 1, algebra 2. But I know that foundations means something very specific in math. I know that, okay, dude? We're also going to be doing a little bit of foundations, true foundations, logic, and things like that. And I'll be studying this for myself, but I'm going to be pulling ideas from this book into my series, into my foundations series for basic math. Do I play chess? No, I do not. I did a little bit during the pandemic, and I was really enjoying it, but the thing is that I love games. I love a lot of games, though. Like, I like so many games that chess is a game that if you want to get good at it, you have to, like, dedicate yourself to chess, I think. Bit of Hope 01. Why do you ask? Did you notice that I have a chess piece as my profile picture on my inactive gaming channel? jcpractices Gaming is an inactive gaming channel, but I would like to restart it. Inactive gaming channel, chess piece, profile picture. There's a double meaning in that profile picture. One, it's just a universal symbol for games. A little more specifically, it's a universal symbol to me about tabletop games, like a game that you play on a table with a friend. But then, yes, there's the idea that if that channel were to grow and succeed and people wanted it, chess is a deep hobby. Chess is the kind of thing I would like to learn and learn live and practice with you all. I really like practice streams and deep hobbies. Chess is a deep hobby. Like, for me, classical guitar is my deep hobby. Math kind of is. Math is a professional pursuit for me. I did a whole undergraduate degree. I was training to go to grad school and become a mathematician. And nowadays I'm trying to get a job as a high school teacher. So it's like, Is it a hobby? Yes, it's still a hobby, dude, because I don't need this math. I do not need this kind of math to teach high school. This kind of math I want to study for myself as a hobby. Like, I truly, even if I'm a high school teacher, I'm still studying math for myself as a hobby, too. Keep the live streams coming. They're great. From a fellow math fan. What's up, LOTR Gamer? I'm glad you're liking them. You can do anything then that's a hobby. Yeah, exactly. You can treat anything like a hobby, dude. This is like I like to think it's a philosophical idea. I studied philosophy as a minor, and it makes some people mad. Like in the guitar stream, I'm playing at a fairly high level. I'm playing classical guitar and studying with a conservatory professor privately and playing at the conservatory level. And people are like, dude, it's not a hobby, bro. Like, stop calling yourself a hobbyist. I'm like, no, I'm a hobbyist and I'm proud of it, dude. Like, tell me about your hobbies. I'm not trying to make money off of the guitar. Ergo, it's a hobby. It doesn't matter how good you are at a thing. You can still treat it like a hobby. And just because something's a hobby doesn't mean you can't become really, really good at it. Okay? Like, dude, I use the word with pride, dude. Like, and what's so cool is that this idea, this philosophy that I've been building for myself in the guitar channel is translating perfectly over here to the math channel, because my claim is you can pick up math as a hobby, right? Like, math can be a hobby. Math can be a hobby.com. That's the playlist for my videos. So, and it's resonating. Like, math can be a hobby. People don't think of it that way. Like, people study math as a professional thing to get into colleges or to become an engineer. Bro, you can also just study math just because it's fun, dude. Even if you have a calculator, you can still triple numbers in your head and then add one to them. Dude, it's still a worthwhile thing. It's better than TikTok, dude. And you all are watching me right now on TikTok. So, like, get off of TikTok and go study some freaking math, dude. Hello, I like you. I like you too. Welcome to my practice stream. What's up, Bessiolek? How are you? Hi, my friend. Thanks for your content. Thank you for being here. Thank you for being here. Kalake, I don't like to say it's a hobby. Why not? Dude, be proud of your hobbies. Your hobby, if your hobby is math, your hobby is cooler than other people's hobbies. I'm not watching you on TikTok, therefore I am better than everyone else. You're still watching me on TikTok, dude. Okay, so, dude, we need 2 more likes. 2 more likes. Only 2 more likes, and I'll do 10 push-ups. I'm going to get you all to encourage me to do 10 push-ups every 10 likes. I forgot to put that in the chat. 10 likes equals 10 push-ups. Hell yeah, thank you. I knew it was going to happen if I asked. All right, thank you all. Let's do some push-ups and then let's do some math. Ah, jeez. All right, hell yeah, dude. Hell yeah. Thank you. Whoa, shit, we're already at 15. Are you streaming on Twitch also? I am, yes. If anybody wants to watch me on Twitch, you can watch me on... I don't know, dude. Most people are here on YouTube. I guess I wouldn't mind building a Twitch as well. Literally watch me wherever you want to watch me. I don't care. I do not care at all. Watch me wherever you want to watch. The important thing is I'm going to study some mathematics and hang out with you all. How are you on chapter 16? Because we're going to jump ahead to chapter 16, dude. Get excited. The thing is that I'm structuring this course, this series, as an intro to proofs and an intro to pure math. And this book is really cool because it is intro to proofs, intro to pure math, and it invites the teacher to use this material and bounce around and follow, build your own course out of this. It is not meant to be read in a linear fashion. And if you took an Intro to Proofs course, the topic that we're going to be talking about today would be like lecture 1 or lecture 2. Like Induction, the topic of section 16, is the very first page of this other book. The very first page is the principle of mathematical induction. So, yeah, dude. Oh, wow, India's protest ended. No way. Are you serious? Yo, Azur, if I want to be a mathematician, would you recommend studying Olympiad math and then studying some more advanced math? Or should I skip the Olympiad math and go straight to more advanced math? I don't know. I've never done Olympiad math. I know some of that stuff. Like, I think that the IMO is legit. The IMO, as I understand it, is a pretty legit exam written by real mathematicians. It's still competition math, and it's still like I don't know, man. I just don't know. I would say that it's a different skill, though. If you want to be a mathematician, do extracurricular math is, I think, the important thing. And I will say that most mathematicians I know did not do competition math in high school. A lot of the mathematicians I know, many of them, most of them probably, did not become interested in math until they were in college. So I would say, dude, that I'm tempted to say that you can skip the IMO completely and do what we're doing. Follow this type of course, because in college, you reset back to the basics. In college, you take an Intro to Proofs course. In college, you take an Intro to Proofs course, whether that's a course based in combinatorics and number theory, or a general purpose discrete math, how to prove it proofs course, or how I'm doing it is proofs with high school math, with pre-calculus. But no matter how you do it, you need to reset back to the basics and start over fresh, and learn how to write mathematical arguments and like really learn how to write and read precise math texts. So, I mean, I would say, because like the thing is that competition math is going to be training your problem solving skills. Full stop. Like, I took the Putnam, though that's the only, I mean, I guess I did like a modeling competition 2 years, and I did some sort of like integration bee once. Dude, like, I did the integration bee, and while in there, I was just like, I do not give a single crap about this thing. I do not care about this thing at all. Like, integration bee, just like get really good at your antiderivatives. Like, dude, who cares? Like, you don't need that. That is a type of math that appeals to some people, and it had negative appeal to me. And kind of the same with modeling, with this math modeling applied math contest. I was like, this is kind of cool, but it's not my thing. I took the Putnam twice, really loved it. Really loved it. I got a 7 out of 100, and I was so proud of that, which is funny. So, like, I do think that you probably can't do super well on the Putnam unless you did competition math in high school and then started really doing real math, quote unquote. I would say if you want to be a mathematician with 100 energy points, put 25 into competition math, high school, but like good competition math, IMO kind of stuff. Put 25 points into IMO, art of problem solving, those types of books and competitions, and put 75 points into abstract algebra, number theory, intro to real analysis. But don't go too far. Don't start trying to study something like algebraic topology or frickin' representation theory or something, dude. Like, if you want to be a mathematician, start, reset, do the basics, and do it really well. Like, start learning elementary number theory, and learn it really well and work through some texts. 7 is a good score. I was proud of a 7, bro. I was like legit, like, hell yeah, dude. I expected a 0. I got a 7. Yeah, number theory book. So I don't know exactly which number theory book is going to be my primary book. I think it might be this one. I like it. It's quite middle level to me. It's small. It's a Dover book. It's cheap. I'll set up an affiliate link if people want it. But then I also have one that's a little bit easier back there in that stack. It's called Rosin. Then I have another one coming in the mail that's arriving tonight, also by Rosin, but a different Rosin. So that one's easier, this one's middle, and then the other Rosin is harder. But yeah, we just need one more like, and I have to do 10 more push-ups, so y'all are gonna, I feel like y'all are gonna beat me up today. Yeah, if you had actuary exams, like that's also equally hardcore, I think. My Putnam professor who was training us, for like preparing for the Putnam, he said like actuary exams were the hardest exams he's ever taken in his life. And he was like the smartest freaking most brilliant mathematician I know. Yeah, like competition math I think is helpful in the sense that they will train your problem solving skills. And there were times during my math undergrad where I was like, I think I just need some stronger problem solving, like just some kind of raw fundamental like kind of problem solving skills. Yeah. So I mean I think that there's some stuff that transfers, but it's not directly related. Like the material is completely different and other stuff. I don't know. All right, hell yeah, dude. Thank you, everybody. Oh yeah, Putnam was hard as hell. Yeah. All right, thank you. Ah, hell yeah, dude. We got 20 push-ups in the intro. Before I even got started. I haven't done any math. I have to get off of TikTok, and I got to start studying some math, too. Okay, so... Well, I'm happy to hear that the protests are over and everything. Your Twitch and YouTube chat are not combined. I have no idea how to do that, Fook Life. That's the challenge. That's why... Dude, Fook Life and other people, also, by the way, Expert T33, thank you for following me on Twitch. If you all want to figure out what's the best way to mix chat, I'm all ears. Restream.io does not do a good job. That was the first thing that I tried before. And I started looking into Stream Elements. I have Stream Elements set up, and it doesn't do it either. Dude, I only care about math. Like, I don't care about you all. I just want to study math. I just want to be here and freaking actually do math. So if you all want to help me get the chats mixed somehow, I think it's probably I think the right way to do it, personally, is, where the fuck, this one. Oops. Okay. Well, there's my classical guitar. I need to get my iPad up on screen. I think the right way to do it, honestly... What? Oh, come on. Come on. No, dude, I'm not doing that. What are you talking about? I'm not doing that, dude. No, you. All right. 24-hour timeout. You're welcome back tomorrow if you want to. All right. No, you, dude. No, you. Anyways, if somebody... Oh, I guess it turns out if I delete somebody's message, it doesn't delete here. Oh well. I like discrete math with ducks. Love how the author combined her favorite hobbies. Ooh, I haven't heard of that. Yes, I do use OBS. I do. So, I mean, I think that the right way. Uh, um, let's get that freaking message off of. I'm not doing that, dude. I mean, I'm trying to study math. You're right, though, that I should get focused on the math. That's for sure. All right, so thank you all for being here. Thank you for hanging out with me while I study. So one thing that's important, I think, is please, everybody, let me know what you want to see out of this course. There's a bunch of people who have followed me to watch me teach and study this book. Let me know, what do you want to see? Because there's so many decisions right now. I have considered completely different types of videos, like completely diametrically opposed, like totally different videos. I've considered, and I'm like, no, I don't think that's how I want to run it. I think I want to run it like a course, like a structured course. And I'm getting comments of people saying like, there's not enough structure. That's not quite as structured as I want. I'm like, I promise you, this is already more structured than I was thinking at one point. So please let me know what you like and what you don't like, what you would like to see more of. You know, things that I'm doing well, things that you think that I could be doing better. Feedback is a gift. I thrive on feedback. The only way I know whether I'm doing the right thing or wrong thing, because like I have so many decisions, like I have so many forks in the road, decisions, do I do this or that? The only way I can know if I'm making the right choices are if you all give me the thumbs up, like and subscribe and leave a comment, all that. Feedback really, truly is a gift. Okay, so basic math. We are now actually going to start a completely new frickin' page. Heck yeah. Wow, we're already at 29 likes. Let's go, dude. That's awesome. Okay, Apple Pencil. Just one more and I have to do 10 more push-ups already. Dude, that's crazy. You got 30 likes? I see 29, so I'm gonna take advantage of that. I still see 29. Practicing. Basic math live. Today is July. What is today? July 27th, 2026. The last time that we were in this chapter was like almost a month ago, so I don't know what else to say. Today we are going to be doing section I need to rebuild this, but whatever. Chapter 16.1 on induction. It says induction and summation. I don't care about the summation. That's not going to be what I focus on in my lecture. We've got that, and we also have this really cool interlude chapter. So it doesn't have a chapter name, but I'm going to call it section I.1 on reading books. I'm going to talk about this, and then section I.1 or section I.2. What is this one again? I don't think it's set theory. I think it's logic. I'm pretty sure it's logic. So I'm practicing right now for my next filmed basic math video, which I hope I just do live today. I hope that I can just film it live while I'm streaming. All right, we got 30 likes. Thank you, everybody. I freaking appreciate it. 10 more push-ups for you all. This is gonna get dangerous. All right, fuck yeah, dude. There's my one F-bomb. I'm not allowed to do that anymore. Thanks, everybody. Let me read. Let me catch up with chat. Congrats on getting a 7. The median score is 0. Yeah, some years the median is a 0, and then some years the median is a 2. I think that they literally don't give ones. So, yeah. It's usually either a 0 or a 2 every year, which is hilarious. What I liked about that exam was the fact that you go in and you expect to get a 0. So if you get anything, you're just really proud of it. You're like, oh, awesome. I think the first year I got a 2, and then the second year I got a 7. So I was like, both times I was like, whoa, damn, dude, I thought I was going to get a 0. So that was cool. How do you know if you've reached mathematical maturity? I know it because I know when I reached math maturity. That's a great question. Let me give you a moment here. This is a really good question. I'm sorry, anybody who's here waiting for me to actually get into the actual math. But Azure 5521 says, and please, anybody in the chat, please chime in on this because I think this is a great question. How do you know if you have reached math maturity? That's a great question. It's just such a vague thing. It's such a damn vague, difficult to say thing. And back to this series that I'm filming. This series aims to build math maturity for people. I'm spinning it and giving the selling point of like, math as a hobby for adults. Like, come back, try math again, do it the right way. But that's like angle 1, and it truly is priority 1. Like, I'm trying to put out the idea math can be a hobby, and man, I will argue that to death, and people have heard me say it, so I'll skip it right now. But math can be a hobby, but then at the same time, when I say learning real math or intro to pure math, I'm talking about building math maturity. Like, you need, like, this book can get you fairly mature, and it's so unusual. This is not the type of book that normally like puts hair on your chest, dude. Like, proverbially, like, usually people learn how to write proofs in a book like this, in like Velleman, or maybe in number theory course, or maybe abstract algebra. My university taught intro to proofs in a intro, undergraduate friendly intro to proofs, intro to abstract algebra course. But what's so cool, this book is very unique. I haven't seen any other book like it. This aims to build mathematical maturity in pre-calculus math, like in middle school, high school math. Basic algebra, geometry, trigonometry, like basic, I don't even think limits are in this book, dude. Like, this is all pre-calculus, the math that people remember and did badly at in high school, but now they're retired and they're interested in trying math again and trying to come back and like prove themselves, like, let's try math again now that I don't have exams. I think it's really kind of a perfect fit for a book that aims to build mathematical maturity. Now, your question, how do you know if you've reached it? It's such a subjective damn thing. It's so hard. You can't really put it into Khan Academy. That's why there's such opportunity here. Traditionally, it's been a master apprentice type model. Like the academia model, if you're a grad student, you have an advisor. And I mean, that's the extreme of it. But if you're an undergrad trying to become a mathematician or, a scientist or something, and you need proof-based math, you have a professor and they grade your homework and they have office hours and you ask them questions. It's like, try to imagine putting like freaking like kung fu. Like, dude, I learned kung fu from Khan Academy. Like, I would be like, no, you fucking didn't, dude. Like, you can't learn kung fu from Khan Academy, dude. Like, what are you talking about? If you want to become a black belt at kung fu, you got to study with a master, and like, there's no way to do that other than like 1-to-1. Like, it's just such a hard thing that takes one-on-one training traditionally. And when you study with a master in something difficult like kung fu or chess or classical guitar or frickin' pure math or something, you know it when your teacher tells you you're there, but you're never fully there either. But at some point, you're working exercises. I would say when you are working exercises and you know on your own if you have a correct proof or not, you don't need somebody else to judge your solution. You know, like that was correct or that was incorrect. There was a logical gap in my argument or not. It's not so much, in my opinion, about whether or not you can solve the problems. That is one thing, obviously. But like I can't solve all the problems in the scary Lang book. Like I have Lang's Algebra book, and it's so much harder, dude, than this book. I can't solve all the problems there, but I still consider myself mathematically mature because I know that I can't solve those problems. Like, whereas when I work problems from Dummett and Foote or, definitely like Gallian, like a more intro level abstract algebra, I don't need a teacher to tell me that a solution was correct. I know that this proof was correct. Like that, I think when you can judge yourself on whether or not your proofs are sound, like logically complete and sound, I think that that's as good of a definition as any, even though that's still simplified. Like math maturity is one of these vague things that's just hard to define. I mean, textbooks will say like this book. This is a math logic book, and it says in the intro, every math book will say at the beginning what its expectations are, what kind of mathematical prerequisites they expect. And in the beginning of this book, it says, we assume somebody already has math maturity. Somebody already knows how to write proofs. Somebody's already gone through this reset back to learning rigorous mathematics, not calculation. Like, we learn the pattern matching, plug and chug, whatever you want to call it, type of math, and then you reset and you learn proof-oriented math. A lot of authors will say mathematical maturity and mean you know how to write proofs. But then there's levels of math maturity. I would say like you've reached real math maturity when you can judge your own proofs and you can read through books on your own. Yeah. Oh, thank you. We're almost at 40 likes already. If we get to 40, I owe you all 10 more push-ups and I'm going to start getting exhausted. That's kind of a weird question. Math maturity is not like a destination, more a process. You are mature in some stuff, immature in some. I'm really curious what you all thought of my response to that. There is a thing that, like textbook authors and mathematicians, math professors will talk about developing math maturity, and it's not a binary yes or no kind of thing. It's a lifelong process, for sure, to agree with Levi. But there's a level of math maturity to where you're like functional and you can say like, yes, I'm ready to read this book, which is designed for third and fourth year undergrads. Okay. I think it's more about time spent with thinking math about maths, doing maths, than the number of books. Yeah, it's definitely not the number of books you read. Definitely not the number at all. It's about like your quality of time spent working on those books. Bro, we're already at 40. Man. Okay, all right. Thank you all. Thank you. Oh, God. All right. 10 more. I owe you all 10 more. Thank you, chat. I don't do push-ups, dude. It's been a year. It's been over a year since I've done anything physical at all. So thank you. Here's 10 more. Okay, dude. Okay. You can watch a video on adding the chat. It's very simple. It takes a minute or so only. Tell me which video to watch. I will watch it. But I'm bored about doing stuff like that. I don't care about mixing Twitch and YouTube. Nobody's even watching me on Twitch anyway, so who cares? Like, just let me know what video, which video. Drop it in the Discord. Here's the chance. Join the Discord, everybody. If you're not already in the Discord, it's a fun, nice little space. And I just think we should be building up math YouTube, dude. Like, math YouTube, math streaming should be a thing. Dude, chess became freaking huge during the pandemic. Like, I don't know if you all follow people like traditional streamers, video game streamers like Ludwig and people like that. Everybody was playing chess during the pandemic. Why aren't they learning math? Like why aren't we just like competing on learning math? Like, dude, it could be, especially now. I mean, whatever your feelings are about AI, like I was just talking about having a teacher judging your math maturity. You can use AI if you want to be your teacher that judges your proofs. I know that sounds disgusting to some people. Me too. I don't really want to use chat for that purpose, but if you want to, it can do a good job. Learn how to write LaTeX, drop your solution, and if you haven't used it in a while, it's getting better by the day. I used to be a software engineer. I used to work and I'm sure most people know this already, but bachelor's math with honors, prep to go to grad school. I was going to go to grad school, become a researcher. Instead, I decided to go make some money. I went to Apple. I worked on iMessage. Then I went to... There were some other cool companies, but I'm going to simplify. I was always doing iOS, but I worked on payments at Lyft. Then I went to Google. I worked on YouTube. I built the widget that lives on your home screen. Then AI took my job. AI. That's supposed to be like the little dead looking smiley face thing. So now I've become an independent, self-employed creator person thing. That's really hard. So next, I want to become a school teacher. And I just want to work with little children. Dude, I enjoy working with people. That's next. So I'm on a journey to become a freaking school teacher and just share my passion for math with little kids. Dude, like I enjoy it so much. And with you all. You all are basically little kids, too. You all are a bunch of little kids as well. So, let's see. I never did math free time as a hobby. Now's the best time to start. It's never too late to pick up a hobby, I think. Yes. Enrico. Let me give you a little moment here, because I think this is important. At Enrico, I'm just going to say that. I'm just going to summarize. I don't know any math. can I watch your videos? Let me know if that's a bad... I think that's an accurate enough paraphrasing. I'm going to say yes. You want the blue thumbnails. The blue thumbnails are a series called Math Can Be a Hobby. Yes, those are designed for anybody. Anybody who wants to learn math. It's starting from the basics. It's starting from addition and multiplication. You can learn with us from the ground up. And it's aimed to build math maturity. Like, back to this other topic. Like, how do you, like, it's actually math done the right way, proof-oriented, logical, deductive process type of math, which is so underrepresented. It's just not shown in the U.S. high school classroom. So, yes, but these live streams... what's another good color for this? Live streams? Like this right now? I don't know, maybe. Some of them. They're really here for the vibes. This is just like a hangout, study with me space. I haven't done any math yet. I'm just hanging out and vibing with you all. Vibes more than math. And some of it is graduate level stuff. Some of it I'm studying is stuff like representation theory. You don't really want to spend your time watching those or trying to understand my representation theory streams, because that is designed for mathematicians. Like, that is graduate level math that I'm studying for myself. But I think it's important to keep doing them because I'm proving to you all I'm studying math as a hobby. Like, I don't need to know representation theory, but I'm learning it because it's fun. And I'm never going to get paid truly to do representation theory. But I'm showing you all and living it that I study math for fun. Like, yeah. All right, let me keep reading. Thank you for your question. Yes, but you want this main series, and you can get to it from this playlist. What do you find when you find a math topic hard to grasp? I need to catch up with chat. Otherwise, I'm never going to catch up and do actual math today. Abstract algebra is incredibly hard, it depends on the teacher, depends on the book. Subhajit, you should, if you want to try to conquer abstract algebra again, you want my week 3 videos. Okay, week 1, which we're on right now, we do 1 week at a time, 1 week high school, and this is foundations. I'm going to study a little bit of true, like, upper division foundations, but week 1 is high school, week 2 is college level, and this is primarily number theory. I'm going to have a little bit of each level within these, but the priority is college level math. And it's the general primary subject is number theory. And then my third weeks are grad level. And the primary topic is representation theory. But really, not just at representation theory, it's rep theory and abstract algebra. And I will talk about abstract algebra all day over there, and I'll work some problems. So if you want to learn abstract algebra better, and at least see somebody who geeks out about it, because I think it's so pretty. I think it's so fun and beautiful. It's not like calculus, dude. Calculus does nothing for me, honestly. Like, if I'm gonna be honest with you, linear algebra, abstract algebra, stuff like representation theory just really turns me on, dude. Like, number theory, all of that does. Like, there's just these two camps, roughly speaking, of algebra versus applied and analysis and calculus. Kind of, I don't know. They're both wonderful, and I've grown to appreciate and love analysis, but I'm an algebraic kind of person. It's, what I enjoy the most. My point here is, unfortunately, you just missed my week on algebra, but I'll talk about that more if you join one of those streams. There's an awkward math puberty phase. I've never heard it, but I love that. The awkward math puberty. The puberty years are really awkward in math. I definitely agree. It just takes time. Oh, hey, what's up, Ming? Dude, good to see you, Ming. Shout outs to Math with Ming. Bro, what's up? I'm sorry, I hope you're still there. YouTube.com/@mathwithming. Awesome math YouTuber / streamer. Analysis kind of guy. From what I can tell, Ming, is that accurate? I think that's accurate. Hey, in Twitch, dude. Saya Jeff, good to see you, bro. Dude, Jeff, do you know that I've small time blown up on YouTube as a math streamer now? I have a 200,000 view video from 2 weeks ago telling people that they should study math as an adult, as a hobby. Dude, I hope you check it out. Yeah, it's really kind of blowing up in a really beautiful way, because as much as I love classical guitar, this person on Twitch knows me for classical guitar. As much as I love classical guitar, I love math equally, the same amount, literally the same. So, yeah. Math teenage years, where you think you know stuff but actually don't. That is such a great analogy. I've never heard math puberty. You're in the math puberty years. That is so real. Math maturity is when a notion feels inevitable to you. Oh, that's nice. I like that. Yeah. Ming says, when a notion feels inevitable. I like that. Math maturity also means how to approach a new subject. Yeah, that's definitely part of it. In classical guitar, my professor calls it a very similar idea as actualization. You all don't know who Chris is, but he calls it in guitar when you're actualized. Kind of when it's sort of when you can work independently, but it's you are your own, you don't need a teacher as much, although everybody always benefits from having a teacher. And, the world-class tennis players still work with coaches. Tennis, math, classical guitar, these really difficult, technical, deep fields like chess or something. I think that people, or kung fu or something, people will keep working with a teacher indefinitely. I think that's kind of, I don't know. That's the thing. But there's still this idea of actualization. You can work somewhat independently when a notion feels inevitable, when you can read a book on your own. Yeah. I did talk about inevitability with JC, but I kind of don't think that's a real mathematical maturity. I don't know, honestly. Yeah, I don't know. Inevitability, I think the idea that Ming is saying there is kind of what I'm saying is like when you can read a book and it makes sense to you on your own. You don't need somebody else to fill in the details or something. Like at least a good book. There's bad books, but yeah. I hope you appreciated the response. The ability of telling when you get something or when you're still not quite there, basically accurate self-assessment. Yes, self-assessment. That's what I'm trying to get at. And that's also like what Chris was saying. Really, self-assessment. When you can judge whether your proof is incomplete. And there are levels of that. If you're working on research level math and you're working on a paper, you still get your papers refereed. You still get them peer reviewed. So, I don't know. There are like some students who are really fluent but still have not much understanding. Yeah, okay. Yes. Yeah, like if you know a lot of stuff with little depth, that I've seen a lot of students like that. They think that they're like, I don't know, working and understanding algebraic topology or something in high school. It's like, no, dude, you should slow down, reset, do the basics, do the fundamentals deeper. Like, I don't think that you're there yet. Like, I'd be very surprised if you're there. I love the apprenticeship model. Yes. Apprenticeship model for anything you want to learn deeply. Yes. Dude, apprenticeship model, master apprentice model, I think is the long-lasting, true educational system that's here to stay. Like, dude, it doesn't scale to a classroom of 30 students. If you need to run a lecture with 200 freaking college students in a calculus lecture hall or a 30 classroom, public school, high school, dude, you can't do that in a one-to-one master apprentice model. But with some new technology and things and, access to some new stuff, like I think that the entire educational system should move more towards something that's like one-to-one. Like you're just in math class for high school. For all of high school, you're just in math class. And you are working with your teacher and you're working at a different pace than the other students in the lecture hall. Maybe you're all working on broadly the same subject, like, I don't know, limits, like calculus limits, but one student is ahead and they're studying from Rudin and somebody else is studying from Stewart, and somebody else is studying Spivak's calculus and somebody, like, I think that somebody could structure a high school education that's more tailored one-to-one with a lot more one-to-one lesson time, like one-to-one instruction, similar to classical guitar, which I've seen. That's the model for like high degree conservatory level, people studying. Like you do studio classes, but everybody's studying one-to-one with the same professor. And there are shared lectures, but not everything. Like, I don't know. I think that the one-to-one master apprentice model, there's just an opportunity to try bringing in some of those ideas to, if somebody could just rebuild the entire high school curriculum, which is crazy, but requires relentless self-honesty. I think other than self-honesty, you need a good mentor who can show you your gaps. That's what I'm talking about too. Mentorship is so important in this sort of stuff. A big sign of understanding a subject well, if you read a textbook or hear a lecture and think, I could have explained it better. Math maturity is more than that, but it's one thing. Yeah. Like, I feel confident to take parts of this book and skip other parts of this book and go deeper on some things, pull in topics from other books. Like Collat's conjecture is not in this book, but I think it belongs perfectly, like as an extra example in the multiplication chapter. Like, dude, I think it's a good idea personally, and I feel confident in that. Even though I don't have a master's degree or a PhD or anything, I feel confident enough to say, yes, we should add extra exercises, and here's an exercise I like from this other book, or my other knowledge of math from some other subject. And I feel confident saying we should show unsolved problems in books. Like in an intro to proofs book, I think that we should be like, now check this one out. This one's really hard and we still don't have a proof for it. How amazing is that? Math is not complete. Math is not done. Like there are hard problems out there. And some of them you can explain to a little kid. Like, yeah. There's a level of confidence and judgment and maturity of reading a book and knowing and being able to do some level of self-assessment about it. That's what we're talking about right now. Okay, so there's a lot of nonsense on this iPad. I need to get off of TikTok and start studying some math, but I'm having a lot of fun with you all. I really am. I'm just joking. Don't worry. Subjective thing. Yep. Studying dynamics. Nice, dude. Proof of push-ups. You just have to hear me breathing hard and sweating, or like my skin getting a little glistening. Speaking of, I know we have 50. I'll get there in a second. Getting ripped. Hell yeah, dude. We'll get there someday. Yeah, you love calculus. That's cool. I want to learn I want to love calculus. I'll get there. It's very hard to do research on your own. Yeah. Like at that level of math, like you're working at a higher level you just can't do something like research independently. I think you need a mentor because that's such a degree of specialization and you're further along in the path. Like, you need the master apprentice model. That's what academia is. That is like you can't put it in Khan Academy about whether or not you can't build a software app that will judge whether or not you deserve a PhD. There's no clear rubric on that. You just need to get a room of experts who have PhDs who say yes or no, this person has it. It's a subjective thing. It's such a subjective thing. You just need like that level of mastery. They just either say, yes, this person deserves a PhD or not yet, next year or something. Like you just can't teach ChatGPT to judge whether or not somebody deserves a PhD, I think. I mean, I don't. Subjective thing. Hey, El Cookie, good to see you. Proof of push-ups, getting ripped. Great summary. Heck yeah. Be curious and humble. So true, dude. What's the difference between being curious about something and getting interested in something? Yeah, yeah. Curiosity is innate, cannot be forced. That's interesting. That's an interesting idea. Acuteness of your goal could be a differentiating factor. Pretty much a newbie when it comes to abstract algebra. No way. Oh, really? Dude, we should teach each other because I feel confident in my undergrad level abstract algebra. Wow, cool, dude. Yeah, I've heard this. Ming, correct me if I'm wrong. I apologize if I'm wrong. I think that you said in your stream that you're streaming from China, right? I know that you mentioned that you're translating from Chinese to English concepts and that's a language barrier challenge from you. Were you trained in China? Do you currently live in China? I mean, I guess YouTube is blocked, right? Still. So I know people get VPNs and all sorts of stuff like that, but were you trained there and now you're in the US? Yeah, because I've heard this idea. The reason I'm saying this is I've heard this idea that the US and a couple of other countries are like a little more leaning toward abstract algebra and these like pure math fields that are not as, it's just the pure math versus applied math kind of distinction. Worldwide, there's more emphasis on applied math, whereas here you have to take abstract algebra and like multiple levels of it. I think it's literally part of the degree requirements for any university in the US. So that's interesting to me that you actually haven't officially taken an abstract algebra course. Linear algebra is what turned me into a math major. Like vector spaces, baby abstract algebra with vector spaces made me say, yo, dude, I'm going to switch from engineering. I was going to do biomedical engineering. Yo, dude, I want to study this. I want to study math. This looks fun. Yeah, go study, say stuff. I'm glad to hear it. Yeah, you're still here. Thanks for the shout out. Of course, of course. Galois theory gave birth to the field of abstract algebra. Yep. Absolutely, dude. Not a dedicated analyst, but applied math traditionally uses more analysis than abstract algebra, perhaps. I do. I mean, I think that's objectively true, right? I mean, for applied math, you need a lot more stuff like stochastic calculus and probability and things that require a lot more analysis. No, I'm not deleting my classical guitar videos. What's up, Cujo Painting? Longtime regular from the guitar channel. Algebra person too, but I'll keep preaching. Even the most boring parts of math are really interesting. That's true. I've grown to appreciate that too. Yeah, like I joke that I don't like analysis, but I've grown to really like it, actually. It's just when I was studying to go to grad school, I just knew that my research interests were going to lean algebraic and foundational. Like, if I were to go to grad school today and pursue that, which I would love to do, if I had infinite time and infinite energy and I could do everything, I would do that and teach at a high school. But I would probably be working in type theory. Like, I don't know if that's a math department or a theoretical CS department, but I'd want to be working in foundations or sometimes philosophy departments. I did math degree, philosophy minor, computer science minor. So I'm really interested in that Venn diagram intersection. Like, type theory is this like really beautiful little intersection point of all of those. Yeah, dude, I really like PDEs when I did better in my applied math classes actually than my pure math classes. I got A's in like all of my like Fourier analysis, differential equations 1 and 2, including some intro to PDEs. Yeah. Evans. Yeah, I really want to learn some PDs. I bought a bunch of PD books back there, and I'd like to do those sometime. Yeah, y'all should know Ming for sure. He's much more mathy than me. I'm here doing push-ups and stuff, but I think math YouTube needs a variety of personalities, and some people who are a little more mathy, a little less mathy, a little more advanced, a little less advanced, etc. Cool. Yeah, Ming, I do think that your channel has a lot of variety of topics, and it seems like it's because you can like lecture on them, whereas I'm more like a student, like a returning student coming back to math and working through books, and I'm deliberately trying to make sure I don't dabble too much. Like, I'm carefully adding new books. And if I add a new book, I try to remove a previous book. Whereas Ming, from what I can tell, it seems like you're ready to like lecture on a variety of topics. So Ming is like taking requests like, tell me what you want to see next weekend, and I'll give a lecture on a topic. You all tell me. Whereas I'm like, no, I'm not going to study JEE math. I'm here working through these books. Yeah, it's just a different format, and I think we need both of them here on YouTube. Areas of applied math. I'd love to just learn more applied math from your channel. I look forward to. Oh, you did your higher ed in Canada. Okay, sick. Okay, you're in Canada. Got it, dude. Got it. I was wondering if you maybe did your undergrad in China and then came over abroad or something. Okay, cool. I'm surprised that Canada doesn't require abstract algebra, but that's okay. That's cool. And yeah, I understand. Like I remember from your stream you mentioned that English is not your first language, which is super awesome. Like your English is perfect, dude. Like I would never have guessed. Like especially in your writing, like your English is completely perfect, dude. Type theory a part of math logic? Yeah, basically. Basically, which I like a lot. I mean, I've gotten paid a lot to think about type systems with Swift, especially in functional programming, and how we can use a type system to our advantage so that we don't write really, really buggy code. Like, I've seen how useful and applied type theory is in the real world. So to me, I'm like kind of interested almost in this applied type theory, like sort of research front stuff, like contributing to lean, for example. Like if I could specialize in work related to building lean and that set of efforts, like that's what I would do if I went to grad school. Oh, Kaya wants to say hi. Kaya. Origins of type theory are computational theory / theoretical CS. Yes, but now it's becoming much more applied. Your lives are more like seminars than lectures. Yeah, that's sick. All right, have a nice day, Levi. Take care, man. All right, I'm catching up. Dude, Arad, no. I've always wanted to, though. That sounds freaking sick. Like, that actually sounds awesome. I was interviewing with a team very adjacent to the compilers team at Apple regarding, like, compilers for iOS and Swift and stuff like that. Like, dude, that stuff sounds awesome to me. Like, to build a compiler and work on like the most modern languages that have these beautiful strict type systems, strong type, strictly typed languages like Swift with inference, and it's so pretty. Yeah, that kind of stuff I would want to focus on if I went to do a master's. Kaya. Yeah. Yeah. Y'all, you all don't even realize we have two cats. We have two cats. She's very hidden. She hides. She doesn't show up as much, but she's also so pretty. Look at the Kaya. She's much more shy. She does not want to be on camera. Okay, I'm finally caught up. Let's do 10 push-ups, and now I can finally get to the math. OMG, second cat. Yeah, we got the, Boolean logic pair over here. We got the true and false, black and white. Yeah. All right, heck yeah, dude. This was like the longest intro. It was an hour-long intro to the stream. I haven't done any math yet. I've ranted about math, and we've talked about a lot of math-related ideas and topics and advice and things like that, but I haven't solved a problem yet, and that's making me antsy. Let's get into it. So, for those following the basic math series, first off, I'm going to, now that I'm finally here, if Hawaii is up, I'm not reading chat. So for about 10 minutes, maybe, I'm going to put away chat, and I'm actually going to try to study a little bit. So for those, I'll be back in 10 minutes. Like, don't worry, I'm not too far away. I'll use timers and everything, okay? Sand timers, goated. These things are goated. Use a timer. Whatever it is that you're trying to learn and work on, use freaking timers, dude. Okay. Where am I? So we got math induction. I know how to do exercise 1. I know how to do exercise 2. I want to do them anyways, again. These are going to be spoilers for anybody who's watching the series, this is not the basic math series. So if you're watching these, you might get some spoilers on exercises and stuff like that. But prove that for all integers n greater than or equal to 1, we have, this is just such a delightfully pretty, lovely fact. I don't know, I feel like we must have proved this in my undergrad number theory class, but it just didn't settle in for me. Like, wait a minute, what are you talking about? If you add the odd integers together, you get square numbers? You get the square numbers? Like, 1 is 1 squared, 1 plus 3 is 2 squared, 1 plus 3 plus 5 is 9, is 3 squared. Like, dude, that's kind of cool. That's really freaking cool. Like, that's just a really delightful fact that you can explain to anybody. Okay, so I know how this goes. This is not designed to be a lecture on induction. So I'm just practicing for myself right now. I'm just kind of preparing my notes for myself of how I would include this in my solution sets for my course, or my series. It's not just a paid course, but also the free series. We prove this by induction. For the base case, the identity holds. Here, let's reword this. The identity holds for the base case as, and I could put parentheses n equal 1, as 1 equals 1 squared. So the base case is typically very easy when you prove something by induction. Thus, assume, or next, we assume that the identity holds for some integer n. And to be a little bit more precise, I'd say for some integer that's at least 1. We know that it works for 1. Now let's assume that it works for some integer that's greater than or equal to 1. Then we show the identity holds for n plus 1, i.e., our goal, which is nowadays this is a technical term, our goal is that we want to show that the sum of this, because previously the odd integers ended at 2n minus 1, so then the next odd integer is 2n plus 1, right? And I like to write my goals in this informal intro to proofs class like this. Equal question mark n plus 1 squared. So the left-hand side, if we assume the left-hand side, we want to rewrite it until it's the right-hand side. 1 plus 3 plus ... 2n minus 1 plus 2n plus 1. This equals, well, I can use associativity to regroup parentheses. And now, by assumption, so here you can give a little justification by associativity. And now, by the inductive assumption, we assume that the identity holds for up to n. So the sum of the first n odd integers is, by assumption, n squared. By the inductive hypothesis, or by the inductive assumption. Now, and this is, we can do this because we showed that it's true at least for one of them, when n is 1. Now we're going to assume it works for some amount. And now we want to show that if it works for some, up to some number, it'll work for the next number as well. Well, this isn't too hard. We can rewrite this without the parentheses, I guess, if we're like really formal about this, but you usually wouldn't write that step. This factors as n plus 1 times n plus 2. Oh, wait. What am I doing? No, that's not right. N plus 1 squared. This is n plus 1 squared. And if we want to give a justification, we can. Like, at some point, you stop writing things like, this is by the distributive property we've talked about in episodes 4 and 5. By the distributive property of multiplication. Thus, if we assume that the proposition is true for n integers, then it also holds for n plus 1. And P of 1 is true. So P of n is true for all n greater than or equal to 1. In my lecture on induction, I will be showing stuff like this, that this is like dominoes. What we're doing is we're showing that P of 1 implies P of 2 implies ... up to some number. We assume that it works up to some point. Maybe n is just 1. Maybe all we've shown is that the base case only shows that it's true for the first number, like that you can knock over the first domino. And then the inductive step says, for any number, we also show that it's true for the next. Then therefore, that one is also going to imply the following one. And so it just keeps going forever, like infinite dominoes. It's a classic analogy, and it works. It just makes sense. Dominoes is just such a perfect, analogy for induction. Okay, so I see we're low on our 5-minute timer. My question to you all that I would love feedback on is, right now, in this Intro to Proofs and Intro to Pure Math course for adults, I have done sections 1.1 1.1 introduces the integers. 1.2 introduces addition. 1.3 introduces multiplication. I think some people are going to be surprised that then we're immediately going to jump to chapter 16.1 on induction. Like, some people are going to be shocked about that, and I'm already getting some criticism from some people that they think that the course seems disorganized. And so I think that this is a little risky, but I don't think that, personally, that somebody couldn't do this. Like, Lang invites the teacher to read this book out of order. And so in this next episode that hopefully I film live here in like 1 hour, hopefully, I'm also going to talk about this interlude chapter. I.1 is on reading books. This is a chapter that just directly speaks to you as the reader about mathematical maturity. Like this topic that we talked about so much earlier on the stream. This interlude says, like, you could read this chapter at any time. You could read it at the very beginning. It's as good of a place as anywhere to put it in the middle of the book. I'm only going to cover in my video today section I.1 on reading math and then I.2 on logic. There's no exercises on logic, so I don't think that there's exercises from that chapter, which is a shame. There really, really should. So I'm going to give the viewer an exercise or two from another book. I mean, there's a lot of examples, so I'll just like use the examples. But I don't think that there's exercises. Yeah, there's no exercises. That's a shame. But for the mathematicians in the chat, I think you all can imagine maybe what this interlude is like. There's also, the next section is introducing set theory and set notation and indices and some other things. And then section 16.1 is induction and summations. Like summation notation. I'm going to invite the viewer to, dude, you don't need to write these in like this kind of scary hieroglyphic form. You can start getting used to it if you want to, but there's nothing wrong, in my opinion. Like, this previous exercise would have said that the summation of odd integers equals n squared. Like, yeah, this is kind of a pretty way to write it, but I prefer this. I honestly prefer this. And I think that it's freaking simpler, man. For something as simple as this to learn induction, I think that the first form is just more clear. And I'll probably just show some examples of this one. Just specific, like when n is 3, when n is 4, when n is 5. Yeah, all right, well, there's 10 minutes. So feedback really is a gift. What do you all think? Is this a scary jump to be going straight from multiplication to induction? Like, we're skipping topics like geometry and trigonometry and the real numbers, rational numbers, Pythagorean theorem, composition of isometries, sine and cosine, parabolas, polynomial functions, formalism, permutations. I think for the audience that I'm targeting, of people who want to see math again and do it the right way, this is now introducing something truly new. Like, adding induction now in episode 6, I think I'll start finally giving some payoff of like, bet you've never seen this before. Here is some real intro to pure math. And you don't need you don't need trigonometry for this. This is still integers. This is still elementary school math, but now we're going to do it deeper. Yeah, so feedback is a gift. Let me put up chat. What's up, folks? Ooh, yeah. Yeah, those are good questions. Like, how do you define induction versus deduction? I'll need to introduce. Thank you. I didn't even make that clear in my head. Like, in logic, I will be in the first half of the video. I'll be talking logic and on reading math and on mathematical maturity. Then part of logic, I need to be talking about deductive logic and deductions. And then how do you define induction as a related but separate topic? It's a cool summation formula. The sum of odds. Yeah, I think it's lovely. It's a lovely one. Ooh, yeah, you started to appreciate pure math and theoretical CS in your master's. Yeah, dude. I've grown to appreciate applied math during the workforce, like working at, engineering jobs. Heck yeah, dude. You're going to do some tensor calculus and complex variables. I've been doing some... Complex variables is an interesting one, man. Like, complex analysis, I think, is this... It's part of, like... To me, that's like one where applied mathematicians and pure mathematicians are just shaking hands and there's some like real unity. Like, I feel like pure mathematicians will claim complex analysis is theirs and applied mathematicians will say complex analysis is theirs. Kind of, in my opinion, like linear algebra. Linear algebra is simultaneously very applied and very pure and proof-oriented. So... It's got a geometric proof with the grid of squares. I should totally learn and show that. Yeah, I bet that there's a nice geometric proof of this one too. I've always thought that there must be a way to show this as a square. I'm curious about it. Nonlinear reading is a must-have skill for self-learners. Yes, and this is a course for self-learners. That's a good connection here. Set a goal and find what part of the book is relevant to that goal. Yeah. In this section on reading books, Lang really says explicitly, start from the middle, and do middle out. Like, a little bit, go previous to understand foundations, definitions, and things, but then also be reading ahead to see applications. Like, where do you... Let's shorthand that to apps. All right, so start from the middle and then go out. You go backward to definitions, and then you also go forward to applications. Like, Lang says that it's very helpful to teach Algebra 1 and basic algebraic manipulation while teaching geometry so that you see applications, and like teaching vector algebra at the same time as Algebra 1. I'm like, dude, that's smart, I think. I wish that math class were taught that way, because then it removes that idea of like, when are we ever going to use this? Because every step along the way, you see these ideas being used. Like, I think that is an interesting approach, and that's partly why I want to take his invitation as a teacher to go middle out. Perhaps you can frame 16.1 also as an interlude. Yeah. Exactly. People following along don't have to go there, but it's already within reach if you want to. I love that. I love that idea very much. I should do that. I should also say, hey, everything in this course is for fun. If you don't care for this topic, if you don't think it's interesting, you can skip it. There's no exams. Like, I'm not going to grade. I'm not going to check your homework. I suggest that this would be a good next topic, but if you don't find it interesting, you can skip it and then read it later or watch these videos in a different order. Yeah, like we're all adults here. We're all adults in this series together, or at least we're watching with parental discretion, with with parental advisory. So, which is amazing. There are parents watching my videos with their kids, and that's like a big responsibility, dude. That's such a big responsibility. Um, so yeah, that's excellent. I think I will use that kind of terminology. This is like an interlude. You can skip it, but if you were to take this exact course on building mathematical maturity, this would be week 1. This would be literally section 1. The very first page of this book is this topic, which is really cool and interesting that Lang includes it in this high school math book. And it's not usually taught in high school, but it's so important. Yeah. Use some definitions. Yeah, it's just a name. Proof by induction is a strategy in proof, and all proofs are deductive. Assume P and show Q. Yeah, but there's some terminology there, and in philosophy, there's discussion about deductive logic, or inductive logic. Inductive logic is like the sun has risen every day till now, so therefore the sun will rise tomorrow as well. It's like, yeah, well, nah, I don't remember. I'd never had enough of a understanding to be able to explain the more broad term of inductive logic. It's a little more technical and confusing than I could try to describe. You'll do complex variables from complex numbers, also known as from the start. Heck yeah, man. Heck yeah. Students understand deduction, where induction may be a new word. Yeah, I should absolutely, if I use a new word, I should relate it to this other word that they've heard. I think that's good teaching. Like, here's a new word. Here's at least a little clue as to why it is related to this other word. That's probably your first question. Is it related to deduction? Yes, kind of. It's like a slightly different thought process, or it's a slightly different format of argument or something. Middle out is also how you actually read research papers. Yeah, dude, exactly. That's what Lang is focusing on. He says, like, you should work, read this thing and then read backward, be able to look up the citations and just the statements of previous mathematical results. And if you want to understand them, read the proofs. If you think it's important for you, read the proofs. Otherwise, you can take them as assumptions and then move forward. Like, the interlude of this book is so pretty. Like, this interlude is really nice because he's writing to a high schooler, but you can tell he's also writing, like, from a mathematician's experience. He's also, like, word for word, everything in this interlude is like, to the research mathematician, you should work middle out. Like, you're not going to understand everything, all of the necessary prerequisites to get to this point. You shouldn't. But you should try to understand the next problem that you're working on and work backward and find the relevant citations and relevant statements. And some of those you should learn, and learn the arguments and understand to a deeper level of depth. But math is not this like grade 1, grade 2, grade 3, grade 4, memorize, learn everything, learn every single thing along the way. That's a lie that we tell high schoolers. That's just such a lie. That's not how real math is done. Like, real math is like this. And it's a nice little section of the book that I want to emphasize that people should actually read if they're following the course. PEMDAS, yeah. What's up, Skittles? Yeah. Skittles is like math. PEMDAS. I know PEMDAS. How's it going, dude? Yeah, induction is, I should compare it to recursion. It really is exactly the same. Um, Bayesian stat and the sunrise problem by Laplace. Ooh, is that Laplace that made that argument? I've heard this before, that inductive logic, like a problem of inductive logic is like saying that the sun has always risen before, so therefore it will rise tomorrow. It's like, what's wrong with that? And a philosopher will be like, well, actually, dot dot dot, which is really weird, and we're not going to go that direction. Calculate the probability of the sun rising tomorrow, given that it has been true for the last n days. Yeah. When am I dropping the Hatcher Chapter 3 videos on cohomology? Funny enough, I just saw that Mathematical Adventures would love to get him in the chat someday. Y'all should tag him in his comments and say, collab with jcpractices, because I'm a big fan of his videos. He just dropped a video today about working through Hatcher. That dude has ripped through so many books. It's like he is a prodigy, man. Like, that guy has worked more mathematics than anybody ever alive. He's like working through a book every 2 days. It's I can't believe it. He's like somebody should give this guy a Fields Medal or tell him to stop reading books and start doing research, because he's like the most prolific mathematician of all time. It's amazing. When are you dropping the homological algebra on abelian categories videos? That sounds fun too. Probably never. Probably never. I don't think I'll ever get there. I'm not a professional. I mean, I kind of am. I'm trying to become a high school teacher. So, like, I'm going back to the basics because I want to teach this to middle schoolers. And middle schoolers usually don't learn induction. Like, this is advanced for my true target audience. I'm trying to get a job. I'm trying to actually get a job. But I want to teach pure math to middle schoolers and high schoolers. Like, maybe that's an honors section of a course. Maybe that's math club. Maybe it's just mixed in as just extra enrichment material to like a regular course. I don't know. Like, I want advice on that from the, department head or whatever. But yeah, I do enjoy this. Yes, I am really enjoying this very much because I'm sharing it with you all. And I know that this is easy. Like, I wouldn't be working this problem. Seriously, like, I wouldn't be working this problem on my own if it was just private. But I'm doing this to share my love of this problem with you all. And I learned this as an adult in my 20s. Like, I learned this topic in my 18, 19, something like that. I know that there's a lot of people out there who haven't seen this before, and I enjoy teaching. Like, I'm like growing to love teaching so much more than doing math. Even though I'm loving doing math and studying math for myself, I'm also equally or more important for me as teaching. So, yes, reading is a skill not seriously taught in math classes, IMO. So, dude, math with Ming. I want to make sure I don't go off too far into tangents on this. Reading is a skill that's not seriously taught in math classes. It's funny because I'd simultaneously say it's overtaught and undertaught. We don't teach how to read math books enough. We don't read we don't teach how to read math. In fact, like, we try to pretend that you should only watch the lectures and learn everything from your teacher who's going to simplify the textbook. Like, from my experience, and from everybody I've talked to, they, think that they should learn all math in the lectures and not read the book. But that's the opposite. And then, so it's not emphasized enough to agree with you on this. But then I'm going to disagree with you also and say that we do way too much word problems. like I teach little kids, and they geek out, dude. They love the Fibonacci numbers. I'm like, hey, let's put a 5-minute timer. Just warm up, practice this, see how far you can get. They love it. They'll just add numbers, and I just tricked them into doing 50 addition problems in a row. You know, like, they love it, and they will not stop. They will compete, and they will, like, just enjoy this and have fun doing this. And then immediately after that, and I have to start working with the worksheets with those kids. You know, I'm a tutor, and there's worksheets I'm supposed to work through. And it says you have 12 apples, and I take away, you know, 4. ... Dude, they do not care. They just do not care. They're like, I don't have any apples. I don't care. Sometimes they're asking, like, what does this word mean? And I wish I remembered specifics, but, like, we're trying to teach vocabulary and reading comprehension skills, like, as math. You know, you should learn how to read a word problem in math class. And yeah, that's probably necessary to some degree, but we keep doing that, and we keep teaching math as this applied math thing, and, like, all math must be shown to have real world applied, you know, word problems. And, like, students just don't care about it. Like, a lot of students just love and really appreciate the pure math stuff. Like, here's a bunch of interesting numbers, add them together. Like, we can be picking interesting math problems like the Fibonacci sequence or Collat's 27. Dude, like, kids love this. I'm practicing this stuff with my wife. Like, dude, like, we will just, like, do, okay, she doesn't want me to talk about that, so I'm not going to anymore. But, like, I, for myself, am setting a 5-minute timer and tracking how far can I get with the Fibonacci numbers, using lots of different techniques and things like that. I'm also trying to see how far can I get in Collat's 27 in a 5-minute timer. And, like, man, it's just fun. Like, it's just fun to multiply and add numbers together. And if you can teach it to just be a fun thing, like, kids really enjoy it. And, you know, there's no word problems at all there. There's no reading. Like, we are trying to teach how to read in math class for elementary students, and that's, I think, the wrong approach. I just really think that's the wrong approach. Math class should be separate from reading class, I think, in elementary school. Like, or maybe not in elementary, because you don't have, like, a dedicated science class as much. But once you're in middle school, high school, I think that math class, like, let math be math, dude. Math, and this is speaking as a very pure math pilled person, but I think that if you represent pure math more in the high school, you're going to actually motivate some students to enjoy it more. And, like, I don't know, I just feel so strongly about this one. Laplace said this. Okay, and Bayesian stats was developed by him. Wow, I didn't know that. Oh, that's so interesting. So I'm glad I made up, like, I made a real analogy that I remembered something from philosophy. That's cool, dude. Okay, thanks for listening to my TED Talk. I hope that these kinds of rants are interesting to you all. Please let me know if I'm overdoing it. Proliferation and perhaps overuse of slides. That is another problem. Teachers are getting lazy as hell with their slides, dude. Teachers are just getting so lazy, and that is not engaging. There's something wonderful about seeing a mathematician spring math and logical ideas out of nothingness on a chalkboard. Like, it's a blank slate, and they just invented math, just appeared out of nowhere on this chalkboard. And you have to, like, you're writing while they're writing. So the ideas need to be slow enough, you know, and compact enough to write the most important ideas on the chalkboard. I don't know. There's just something really pure about that the way math has been taught that way for thousands of years. Like slide decks are just kind of taking away something, you know. I really think that very much. Olympiads, we talked about this earlier actually. You could rewind surfer. I'm not going to reiterate this earlier, but somebody, oh dude, I don't know if I wrote it on the, I wish I did. Yeah, I didn't. Well, I went on like a 30-minute rant about this earlier in the stream. So if you rewind, you could try to find it. We talked about the competition math. I think 25% of energy points into competition math, 75% of time and energy into learning college level math. But do college level math slowly. Don't rush through it. Do stuff, prioritize depth. Yeah, induct high school kids to IMO stuff. Actually, that's what I'm trying to do. I'm trying to sell myself as a teacher that like I can run math club and I can teach pre-college students, like pre-math majors. Like I want to like, run math club for like future Putnam students and stuff like that. I think I could do that. Math really is its own genre of book. Yeah, true. Well, sorry, man, trying to push the engagement stat more, not meant to distract you. No, I love the discussion. I think that this is valuable. Like, y'all, please let me know if I'm going too far off topic. Like, the engagement is so valuable. Yeah. So I don't know about ninth graders reading real analysis, but linear algebra, yes. I think so very much. I'm using that example as like, dude, in my course that I'm teaching on basic math, like lecture 1, lecture 2, I introduced addition on the integers, and I'm immediately also introducing addition of square matrices. Like, I'm actually showing, like, okay, we now know addition of numbers. Guess what? You can put those numbers in two neat little boxes, neat little square boxes, and add those together. And now you have 9 addition problems. Do it this way, like you can start introducing matrices and the beginnings of linear algebra. You can teach linear algebra the whole way through the entire high school math curriculum. Like, I feel so strongly about that. And yes, you can start introducing things like limits early on. And then, like, every step along the way, it's like, oh, I remember seeing that topic before. Now we're just doing it in more depth. Like, yeah. That's so cool. Not enough active engagement, too much passive drilling. Yeah. Yep. You were there for all the kids, and the weaker ones are the ones who need your help and need your attention more. Like the kids who are ahead, you're not working with as much. Yeah. But then I think that we need resources for the more advanced kids too. I don't know. Mm-hmm. Yeah. Right now I can only talk about the US. I've only ever lived in the US, so I don't want to assume anywhere else. But in the US, the advanced kids go to math club and they start doing really hard integral problems for Olympiad math, or like for integration B, or like they just do harder calculation problems from what I've seen. They do harder calculation problems, but there's not usually experience and exposure to proof-based pure math even for the advanced kids. That is something that usually you learn in college. There are programs that are targeting high schoolers and middle schoolers, but that's like, it's the exception. It's so rare. But we just need more of it. I think we need way more of it. Yes, and there's demand. There is clear demand from people about this. And it's a teacher's job. I think, yeah, Ming, it's a teacher's job to try to tailor the classroom to their students. Like, I imagine if I have 10 to 15 students and they are interested in this topic, I will focus on that topic and I'll deprioritize other topics. But they're still going to be learning math. They're still going to be learning math reasoning, and I would be shaping the curriculum of the year to the interest of students. And now you can only do this in a private school. You like, if you are in a public school, you're not allowed to teach outside of the standard curriculum. So yeah, I want to teach at a private school where I can have more flexibility to tailor my courses to the students and what's going to benefit them the most. I mean, I wish I could do that at a public school, but that's not the reality of the world that we're in right now. Um, yeah, and also on top of that, 10 to 15 student classrooms as opposed to 20 to 30 student classrooms. Like, scaling, like, that individualized attention doesn't scale. It's not a linear thing. Like, it's a combinatorial problem. 20 students is much harder to tailor than 15. um, yeah, not all students are going to be excited by math, but not all students are going to be excited by Romeo and Juliet either. But you still need to learn how to read and write. You still need to learn how to problem solve. And dude, don't come into my class and say that Romeo and Juliet is not art. Like, dude, you're not allowed to say that Romeo and Juliet is not art. I think it's art, okay? I think math is art. Um, and we're in this together. You have to learn how to problem solve. You have to learn some basic numerical fluency, but most importantly, abstraction, problem solving. That's what people pay for in jobs. That's what you will get paid for someday. It's not how to solve a quadratic formula. It's how to problem solve and take an abstract, difficult problem, break it down to parts, and execute on that. And math is the best place to learn problem solving because it's fun and it's pretty. It's an art field. So yeah, you can do you can do a lot of linear algebra early. Yeah. You can only speak to the Danish system. Even then, only this was about a decade ago. Happy if you show some flawed induction proofs, like all horses are of the same color. Ooh, I don't even know that one. I've forgotten that one. That might be in this math intro to logic. Thank you, dude. All right, I'm finally caught up on chat. Subhajit Paul. All horses are of the same. I mean, yeah, this is like inductive logic, similar to the sun will always rise, because it rose yesterday and the day before that, and every day of my entire life. Every single horse I've ever seen has been this color. Therefore, all horses are of this color. That's a good. I mean, I need to look up if there's anything more subtle than that, but I think that's the flaw with inductive logic. But induction in math means something very clear, concrete, and induction in math is a deductive argument. But it's still taking this step of just like assume that it works to some point, then show a deductive step, deduce that it's then true for the next one. So it's purely deductive. Yeah, induction in math is purely deductive, but it's not so it's not the problem of induction in philosophy and more broad logic, but there still feels like there's something kind of funny, something kind of magical about this inductive argument in math. Yeah, it is an overloading of words, and I remember being very confused about this as a math major, taking philosophy classes. I was like, what are you talking about? There's nothing wrong with induction. We use induction all the time. So I was very confused about philosophy classes saying induction was kind of wrong or bad or something. And then later I finally understood that we're talking about something different. It's an overloading of words. Whew, okay, that was fun. Thank you, everybody. I hope you all are having fun. Please let me know. We are here hanging out, vibing, and meeting other math enthusiasts. This is like office hours, kind of. You're not going to get a real math lecture out of these live streams. Like, let's all just recognize that and appreciate this for what it is. It's a live stream. We're chatting math and talking about a bunch of stuff. But if people are here who actually want to learn math, you could watch my Math Can Be a Hobby series. mathcanbeahobby.com, lectures on basic mathematics by Lang. But even more, why didn't they give that a link? That's so annoying. YouTube, so buggy, dude. It's such a buggy app, dude. All right, HTTPS mathcanbeahobby.com, playlist of lectures on basic mathematics by Lang. So if people want to learn real math lectures, that's not really what these live streams are built for. These live streams are fun. Like, they're just fun. I hope you're having fun. I'm having fun. I don't want to stop doing them in any way. I hope you all are enjoying it. But yeah, let's do another problem. I'm going to take a little more notes and think about what I want to structure my lecture on today. But first, I see we're at 66 push-ups now, or 66 likes, so thank you, everybody. Here's 10 more. I appreciate it. All right, heck yeah, dude. Whew. Thank you for watching. I'm finally caught up on chat. Let's do some work. I'm gonna work an exercise. So let's put away chat. I'm gonna give this about 10 minutes or so, trying to work an exercise or take some notes, and then I'll be back. All right, be right back. Chat amongst yourselves. Join the Discord if you haven't already. I just dropped a link to it. And I do look forward to reading this horses argument, or the logical fallacy about horses. I mean, I've heard this one before, but I'm forgetting details on it. Yo, Leroy, what's up, dude? I'm gonna try to film my next episode in the series. Leroy's following the course closely. I'm going to try to film my next lecture live here by the end of this live stream. We'll see if I can actually do it. I hope so. All right. Let's lock in and do a little note-taking and problems. All right. Be right back. Be back in 10 minutes or so. Cool. Chat is put away. Okay, so we're going to do, Leroy, we're going to do a big jump in this book because the point of this course is not pre-calculus. The point of this book is developing mathematical maturity. And in courses where you do this in college, you can really learn math maturity with a lot of different subjects, and often it's number theory. Like page 1 is going to be this topic that I'm doing called induction and logic. So in this book, that's chapter 16. We're jumping all the way from chapter 1 to chapter 16, and there's a method to the madness. It makes sense. It really, I promise you, it makes sense. So get excited. You're going to learn something truly new with this new video that I'm going to be doing. So that's, I think, exciting. Okay. So I want to read, if you haven't read this already, Leroy, you want to read the interlude on logic and mathematical expressions. It's an interlude chapter that starts on page 93. From 93 to 90, I don't know, 93 to 100, something like that. So I'm going to reread this and try to think of what I want to pull from it for my lecture. So I read this last night, section I1. Today I want to read right now, and I think I got enough notes on this. In section I2, this is Lang's Introduction to Logic. We need to always keep in mind what's an assumption and what's a proof. What are we assuming? What have we proven? What do we mean by a proof? Part of this, proofs are assumptions plus rules of deduction, or assumptions and deductions. Deductions follow certain rules. We need to understand what rules we're allowed to use in our deductions. And in this book, we're going to just give this a light treatment to say our rules of induction are common sense, which is, he knows what he's doing saying that. Now, another book is going to treat this much more formally and rigorously, but in this book, at this level, common sense. Just think of it as common sense. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Like, that is a deductive argument. Assume this, therefore this. That's a great classic example. Lang says we use if-then statements when one statement implies another. For instance, we use sentences like, so I do think I want to use his examples here. So he has an example that says that our deductions are a string of if-then statements. For example, if 2x equals 5, then x equals 5/2. Right? This is a true statement patterned after the general sentence structure, if A, then B. The converse, so here's another example. I'm going to split this as a separate example that he's giving. The converse, or really this is a definition. Everything's somewhat arbitrary, whether you call it a definition or an example. The converse of a statement, if A, then B, is the statement, if B, then A. The converse of a statement is not always true. Like if you assume a statement, the converse sometimes is false. And I want you all to try to think of examples where that is true. In our previous example, we had the converse would be if x equals 5/2, then 2x equals 5. In this case, it is true. In this case, we see that the converse is also true. Whenever we meet such a situation, we say that 2x equals 5 if and only if x equals 5/2. Or A, wait. Yeah, he uses something strange. But I'm just going to simplify this and say, we say A if and only if B. If and only if means, in symbols, which Lang does not like. Lang does not like these logical symbols, which used to be very fashionable. And over time, we have kind of moved away from thinking that all math should be written in a few formal symbols. And we've moved toward writing math in full paragraphs again. Thank God. But you will still see lots of symbols like this, especially on a blackboard, where they're just much faster to write. Like a lecturer will write this, but if they were writing a textbook, they would write it out and say if and only if. But it's just so much faster to write A if and only if B. Like combining both of those implications, A implies B and B implies A, we could write it as a double arrow. This double arrow kind of sucks. Let's try it again. A double arrow says that these two are equivalent, but there are cases that are not. Like, I gave another example, like Socrates is mortal if and only if Socrates is a man, right? This is not true. There can be multiple people named Socrates. We may not be referring to the Socrates that we all, know and love and read about. There are mortals who are not men, of course. There's Luna. Luna is mortal. There are women in the world. There are lots of people who are mortals who are not men. So this is a false mathematical statement, or this is a false logical sentence. Now, if Socrates is a man, then Socrates is mortal. That sentence is true, right? But mortal does not imply man, whereas man does imply mortal. So these mortal and man are not equivalent. Don't need to elaborate on that any further. But this is just a very, very classic example in logic. And so he gives a good example here. Lang gives this example for a non-equivalent statement. Example. The assertion, if x equals -3, then x squared equals 9. This statement is true, right? But if x squared equals 9, then x equals -3, this is false, right? Because -3 is not the only number that squares to 9. There's also +3. I really like this constructed example because it's just giving us such a good example of, like, in context of learning logic, this rule that when you take the square root of both sides of an equation, you must remember the plus and minus. That's like this pattern matching form of math that you learn a bunch of rules. But what really we're doing with something like that is all of these if-then statements. If, then, right? Like, if x squared equals 9, then x equals -3, or x equals +3. We need this part for the sentence to be true. There's two possibilities if x squared is 9. Now, there might be more. Are there more? No, I don't think so. In some weird number system, there might be others. But, I mean, certainly if you were only working in the positive numbers, there's only one solution. So there's one example. But in our standard multiplication of the integers, of the rational numbers, of the real numbers, and of the complex numbers, in all of these number systems, if x squared equals 9, then x equals -3 or +3. But in the natural numbers, which is also a very interesting, valid, world of math to study, in this world, if x squared equals 9, then x equals +3, this sentence is true if you are assuming positive numbers, if you're only working in the domain of positive or non-negative integers. So here's a great kind of example where you need to understand the if-then structure in math. Like, math is not just about calculating numbers and just writing a string of equalities. Truly, math is a bunch of these if-then sentences. If two lines are perpendicular, then they have a point in common is a true statement. Its converse, if two lines have a point in common, then they are perpendicular, is a false statement. That's excellent. Two circles are congruent if and only if they have the same radius is a true statement. We often give proofs by what is called the method of contradiction. That's so cool that he does this. We want to prove that a certain statement A is true. To do this, we suppose that A is false, and then by logical reasoning, starting from the supposition that A is false, we arrive at an absurdity, or at the contradiction of a true statement. We then conclude that our supposition A is false cannot hold, whence A must be true. An example of this occurred when we proved that square root of 2 is not a rational number. I was just going to say that's the classic example of a proof by contradiction. So I will allude to this. Some are true, some are... Yeah, this is such a cool book, dude. It's such a good book, I think. But I'm very pure math pilled. I'm very post mature in math, so it's hard for me to put myself in the headspace of somebody who has not yet learned proofs. I don't know. It's just a very experimental book, I think. But it's so cool to teach these examples and this stuff at this level and with these examples as opposed to other types of examples. Give me 1 second. Okay, so I just think that these are just such terrific examples, dude. Because they just find so many common gotchas that people are confused by in high school math, and that the teachers explain, but they never fully correctly explain in detail, because that would take you into logic, which feels like it's out of the syllabus and it's not on the SAT test and blah, blah, blah. Like, okay, I need to take a quick break. I will be back in 5 minutes. BRB, BRB. Hey, what's up, chat? What's up? I think now is a good moment for me to, ooh, yeah, that's a good idea. Show that equivalent statements are associative. That's a good idea. I mean, that could be something I mentioned. Yeah, that's a great idea. I mean, that gives an example, because I've been talking about associativity so much. Why are you doing guitar? Because I love it, dude. I love it. It's just a hobby, but I freaking love guitar. Why not? Like, that's, dude, why not? Just freaking do things because you love it. Like, that's what I'm trying to tell people. Get a hobby, dude. Get a hobby. It's going to improve your life so much to get, like, a meaningful, deep hobby. Okay, like, first, get a hobby. Secondly, some hobbies are better than others. Some I'm sorry, some are just better than others. Get a deep hobby. In my opinion, I love, like, there's a lot of great hobbies, but I think that there's a philosophical argument to be made that learning the classical guitar is objectively better than scrolling TikTok. Learning pure mathematics for fun is objectively better than scrolling TikTok. This is a deep philosophical question that does not have a clear answer. It needs a strong argument, one side versus the other. That is a philosophical debate, and I could argue the counter argument, but I personally would favor the argument that classical guitar is objectively better than TikTok. So if I'm not practicing guitar or math, I'm scrolling TikTok, and that's not a good thing. I don't like it as much, you know? Lock in, smile. Okay, heck yeah. Ocean cam, yeah. All those little 1 minute videos are from a vacation 2 months ago. And like, dude, it was just such an incredible experience. It was my second ever time in Hawaii. Both of them were for weddings, but this time we didn't just go to Honolulu. Like, we went to Kauai, and it was like, oh my God, now I get it. This is why Hawaii is so amazing. Like, dude, Hawaii was incredible. If you ever get a chance, highly recommend. Could be solving the wave equation. Feels appropriate. Ooh. Oh, yeah, because of the waves. Yeah, nice. Thank you. Thank you for that. Time to teach those kids some lean. I would love to. Not even joking. I know you're probably joking. I think that we would benefit by removing calculus and teach kids lean instead. I actually think that they should learn lean instead of calculus in high school. I'm not joking about that. I would recommend that my kid learns lean in high school instead of calculus. Women famously are immortal. Yeah. Is lean an acronym? No, it shouldn't be capitalized. But it's a programming language for mathematics. It's a brand new programming language for math, and it's so cool. It's a hot new thing in math, but it's also at the intersection of my professional experience with strongly typed functional programming languages. I'm a software engineer. I'm not a mathematician. I worked for 10 years in Silicon Valley at fancy companies like Apple and Google and Lyft. And we used a lot of the same ideas as lean. So once it started hitting the math scene, as a former math major, I was like, this is so cool. It's like Swift, but for mathematics, and that's amazing. Yeah, it's actually very neat. It's actually very nice. And dude, I think a lot of people should be studying computer science and programming instead of math as their like raw fundamental problem solving skills at the high school level. Like, I think that kids would be better off saving calculus for college, depending, but like a lot of people would be better off waiting till college to do calculus the right way and do calculus like really well in college and work on your foundations more in high school. Foundations including lean, including stuff like number theory, and yeah. Implication is a logical operator. Yeah, kind of. When you begin stringing several statements together with implication arrows, it usually does not mean what you think it does. Yeah, I don't know. I mean, there's a correct way to use it. I'm not sure what you're thinking of. But yes, it's a logical operator, takes two truth values and returns another. That is definitely true. Yeah, that is true. Um, yes, then and only then. That is, I haven't heard that, but I like it. It is confusing that if and only if doesn't match the order of the arrows, and Ling talks about that in his section. I don't know if I will try to refer to that somehow in the video, I think. Ooh, you've got a stream on fundamentals this week. Hell yeah, dude. Hell yeah. Everybody should follow Ming. I gave this earlier. Here's a link. Y'all should totally know about Math with Ming. He is a fellow math streamer, and we need 10 times as many math streamers. Um, Dude, like, video game streamers are so competitive because it's such a saturated market. There's so many video game streamers that they're just so hyper competitive. I think math, like, dude, at least right now, it's such a like rising tide lifts all boats kind of thing because we're not competing for the same viewers from math streams. We should be competing for the viewers, taking viewers away from video game streams. Like, there's so many people watching video game streams instead of math streams that I think it's like really a rising tide lifts all boats kind of thing. I think it's the same thing for classical guitar too, but I'm not going to, rant about that as much as I could. Yeah, everybody. So my point is, I am very open to collabing with anybody who wants to collab, and I really do think somebody said the phrase "teamwork makes the dream work," and I had never heard that before. That's such a grossly saccharine sweet phrase. Like, I worked at big tech companies and we had all these like little like sayings like rising tide lifts all boats, and like you roll your eyes at that stuff, but it is true. Like, those are sayings for a reason. There's real truth in that. Like, rising tide lifts all boats, like we're more than the sum of the parts or whatever. Like, yeah, I don't know. So I'm down to collab with anybody, and you all should absolutely be checking out Ming and Leo lectures and K Theory and the few other math streamers that are out there. I've heard of Don Factorial, but I haven't yet been to his stream yet. But yeah, like, it's so cool to be finding other math streamers out here. When is your stream on fundamentals, Ming? I definitely want to try to catch that. Um, for me, I always fix it in my head by thinking A if B, right? If B, then A. Like, A if B is just a reformulation of what we usually think of. If B, then A. So then I remind myself, okay, if is the left arrow and only if is the other arrow. Lang says nobody in their right mind says A only if B. Like, nobody says that. So we will never say that, but I'm just pointing it out that I don't know. Yeah, he says something about that, like, warning, nobody only says A only if B. So we would always say, oh shit, what is it? If A then B, or A if and only if B. Yeah, I'll have to find my way to frame that. Well, such a cool BRB screen. I've got a lot of them, man. Because that's just part of this playlist. How do I do this? These are all the music we're listening to. all of it is my classical guitar. I have a secondary channel in classical guitar deliberate practice. So if anybody, like, you would help me out, seriously, even if you don't watch very often. If you subscribe to my classical guitar channel, that would help me grow as a math streamer. Like, even if you don't like math, even if you don't like classical guitar, if you subscribe to that channel, I think that would help me grow as a math streamer. And let's build a cool little feedback loop between the two. Like, that would be sick, because I have a rival. I have a rival in classical guitar, and it would make me so happy if someday I can catch up to this rival. Lol. If you know, you know. If you know, you know. Chat really doesn't like posts with multiple if and only ifs. That's shorthand. Most of these are filmed from live streams where I gave a live concert. Like, this one was my fall live concert from last fall. I think that this song is, I don't hear it, but I think that this one is La Alborada. And all this is copyright-free public domain music, so that's kind of cool. That's like quite a way to get your own music. Why are you doing guitar? It's because I love it. Oh, you subbed to my channel. Thank you, bro. What kind of math are we training? We are learning Introduction to Math. Oh, the spaceship operator. I don't remember that. Music is awesome. Music is. I mean, it's so similar. It really is. There's a saying that music and math are related, and they are in some ways, and they're not in other ways. They're not the same, but they're similar. Okay, this is hilarious. This is such a nerdy joke. Dude, that is great. Okay, where is it? Dude, that's awesome. I'm going to steal this, and I'm going to claim that this is mine. I'm going to forever. Everything in the chat is MIT, open source, public. Everything in chat is MIT licensed, so I'm going to claim that this was mine. At jcpractices says, where is it? I lost it. Where'd it go? jcpractices says, theorem. There exists a partial ordering over the set of all hobbies. There exists. That's really good. A partial ordering over the set of all hobbies. I like that one. Yeah. Over the set of all hobbies. I love it. Yes. Everything is greater than TikTok. Everything else is tied, and TikTok is the least element. That's the theorem. Done. Proof. Okay, all right, fine. It wasn't me. It wasn't me. I'll come clean. Somebody named Math with Ming said that, and that's a good one. You have to be really, really nerdy to understand this one, but it's a good one. But I will claim it as my own from now on. That's a good one. Don't get a hobby, get a maximal hobby. That's also really good. Okay, that's... All right. I also said this. Corollary. Don't get a hobby. Get a maximal. Is there a least upper bound? Is there a least upper bound property on the set of hobbies? Oh, is there a least upper bound? Okay. Some people out there say that Christian said this one, but that's a lie. That's a dirty lie. I said this one. This was mine. This was my idea. Joking. Joking. I always give credit to others, you know. I always do. Don't worry. Basic proofwriting skills essential for all areas of math. Yeah, this is intro to math. Dude, this is intro to real math, to actual math. You've never learned real math before. Yeah, you do. I don't know, man. You need calculus, but you can learn it in college, was my point. Like, you can learn calculus in college. And a lot of people don't need calculus. You don't need calculus to learn how to program. To be a good coder, you need discrete math so much more than calculus. You need proofwriting. You need the mathematical maturity to be able to read proofs in data structures and algorithms. You don't need calculus to be a computer programmer. And that is by far the most widespread, largest industry of technical jobs right now, I think, still. ChatGPT's wrecking that industry, but still, I think that's a large, if not primary, sector of technical jobs in the US. Probably worldwide, too. And you don't need calculus. You just don't. Like the assumption that all math leads to calculus is a holdover from the space race. That's a holdover from, you know, when launching satellites and rockets and sending people to the moon, supposedly. It's a holdover from that, right? You needed calculus very hardcore to compete with the Soviets, to get men into outer space, etc. Men and women. But nowadays, linear algebra is more important. Linear algebra and programming skills, discrete math, is actually just so much more important. And this, public school curriculum is lagging. It's a lagging indicator. Nowadays, linear algebra is so much more. Linear algebra is the new calculus today. We should be teaching it in high school. A lot of people have technical jobs and never need calculus. A lot of people. Computer science and programming tends just to be more fun to more people. Yes. And that's why I think calculus should be an option in high school. Yeah. If you want to go into traditional engineering fields or economics or something, or so many other fields that need calculus, but you should also have an equal path to linear algebra and programming and logic and pure math, argumentation, dude, we should be offering proofwriting in high school for pre-law students, because a lot of people in high school want to go to law school, and bro, are you kidding me? Proofwriting is critical. Understanding mathematical deductive reasoning is foundational to law, at a deep philosophical level, going back to Aristotle and political philosophy. Proofwriting is a core liberal arts field that leads to law directly, and it predates calculus quite literally. And lawyers don't need calculus. Attorneys don't need calculus, but they do need mathematical reasoning skills, indirectly or directly. We should be teaching proofwriting in high school, I think. Or programming. You should be getting your problem solving, your raw problem solving ability from programming, or proofwriting, or these other options that are just not calculus. Okay, assuming you will actually use math for anything, you really need calculus. False. I've used math all the time as a programmer at Google, Apple, Lyft. I never needed calculus at Google, Apple, Lyft. Counterexample. I just gave you a counterexample. I just proved my claim by counterexample. I disproved your claim by counterexample, that is. Thanks for subbing, Edition Henry. Here's your chance, everybody. If you want to help me grow as a YouTuber, please do hit the like and subscribe. It helps so much more than you realize. Like, it tells YouTube to show the stream to more people. And in return, I'll do push-ups. I already owe you 10. Once I get to the bottom of chat, I owe you 10. And it looks like I'm going to owe you 20 if we get 2 more likes. We just need 2 more likes, and I'll owe you 20 push-ups. And I don't do push-ups, so this is getting difficult for me. I think no matter the math CES subject, the point is to learn how to learn math. Yeah, exactly. Seems there's a nice little group of math streamers converging. Yeah, dude, absolutely. John Leo Ming, don't forget K-Theory. K-Theory is awesome. He had a bad experience recently because somebody is horrible, but K-Theory is just great. Y'all should know K-Theory as well. And let's all encourage him to start streaming again, because we need K, out here on Math YouTube. We really do. Why is what false? X could be 3, but it could also be something else. Wait, how have you never heard that phrase before? Which one? I apologize. There's a lot of things I don't know. Maybe I learned something new. Oh, the hating algebra? I know Boolean algebra. I just reread. I definitely know Boolean algebra. I don't know hating, though. That's what I saw. Math teachers in high school often use an inverse implication arrow. Yeah. We'll schedule a fundamental stream today, trying to think of a thumbnail. See, here's the hack that I've learned over time. As a streamer, you shouldn't have to be making thumbnails every day, dude. Like, I don't know, Ming, if you don't already stream on Twitch, I highly recommend it. Which reminds me, I'm sorry, Twitch, I've forgotten about Twitch. I've literally actually forgotten about Twitch today. There are people watching me over there and commenting, and they're like, bro doesn't read chat. I'm sorry. Okay, not too many. Oh, well, I missed some. I love number theory. To know how I got here, are you doing a math lecture? Yes and no. I know that there were others earlier. Twitch, I'm sorry. YouTube is where the party is, if you haven't figured that out already. But I love my Twitch folks as well. Ming, if you're not multi-streaming to Twitch and your internet connection can handle it, I highly recommend it. I think everybody should multi-stream. Don't go all in on one of these techno-feudalist platforms. Diversify. Just diversify. I can only say that with so much conviction. And besides, yeah, I don't know. Like, Twitch is awesome in its own ways. I think streamers should multi-stream. And people will watch. You'll just reach a different audience. Some people prefer Twitch. Some people prefer YouTube. I think that there are more people interested in math on YouTube than the number of people interested in math on Twitch. I think there's more people interested in classical music on YouTube than the number of people interested in classical music on Twitch. So I prioritize YouTube streaming, but I also think Twitch is important. So if people prefer it, feel free to watch me there. 7 push-ups for you. I owe you 20, actually. I'm so close to catching up. Yeah, I think everybody uses if A, then B. Always. Electrical guitar player, can we still hang out? No. Electrical guitar sucks. Do you have a good musical ear for guitar? Yeah, I mean, I think I'm pretty well trained, over time. Is the set of all hobbies well defined? No, I think that this would be my life's work if we could mathematically define the set of all hobbies and prove this theorem that there exists a partial ordering over the set of all hobbies. This is my research theorem. I'm going to get a PhD in this. Ming and I are going to be racing right now, to here we have Math with Ming versus jcpractices. We are racing to prove this fundamental theorem of hobbies. And one, let the best man win. Versus, there it is. Induction is one of the most boring and useless maths. I'm going to try my best to make it fun. I'm going to try my best. The set of all sets paradoxes, yeah. Zorn's lemma stuff, no. Linear algebra and calculus should both be offered, yep. And many people should take both, yep. I think you could teach both at the same time. I think it should be the same class. You should teach a watered down, not watered down, but restricted version, like a restricted version of linear algebra and calculus at the same time. Very much. And it should not replace linear algebra and calculus at the university level. But you should be able to take the honors linear algebra and honors calculus at university because you took the restricted blended course in high school. That's how I would structure my classroom if I had infinite power, which I do here on YouTube. I can do what I want here, which is awesome. So you all are going to be learning restricted levels of calculus, linear algebra, number theory, logic, abstract algebra, etc. Can confirm, I did calculus and I have no job. And as a mathematician, you don't really use much calculus. Heck yeah, good to have you on board on my team. Gilbert Strang says calculus is hard because of the curviness. Linear algebra is hard because of the high dimension. I really like that. I haven't heard that, but yep. Bingo. Teamwork makes the dream work. That phrase, lol. It's funny. Yeah, it's a good one. Yeah, I hadn't heard it until recently. How have I not heard it? It's great. Hating was, yeah. Kay said he's taking part of some research collaboration nowadays, and that's why he doesn't stream as much. He already recovered his channel and all that. I know, yeah, in my head, it's like, oh, he's like upset that he got hacked, which I would be upset about. I'd be like, dude, it's not worth it. This was not worth it. Like, screw you, screw you, YouTube. Like, somebody ruined the party for all of us. But I know that, yeah, he said that his life is just getting busier right now, and he's, like, doing actual real research and shit, because he's an actual mathematician, whereas I'm, like, a loser frickin' hobbyist streamer. Like, I'm just like this degenerate dude who's trying to pursue YouTube as the primary thing. I'm just this freaking degenerate, like jobless, like unemployed person. Like, whereas Kay and Ming and all of you all are actual serious mathematicians. So, yeah, what's up, Jadugar? How are you? Good advice. Gonna do 80 push-ups. I'm gonna do 20. This is not a triangle number thing. We are doing 10 for every 10. Teach linear algebra in R2 and R3 in high school. Yeah, seriously, for real. Where was I? YouTube has like a weird buggy chat thing. I'm getting so close. Where I lost my place. It keeps happening. Electrical guitar player, no. I do not associate with classical or with electrical guitarists. Priority fight, just like in actual math research. It's a real thing, right? Like, don't people steal other people's ideas and then you've just worked on a PhD for 5 years and now somebody else proved that result and and then you're just shit out of luck. Like, isn't that crazy? Like, I've heard of that happening. Um, that totally happens. Teamwork makes the dream. Oh, I'm finally at the bottom of chat. Kay's doing actual real work nowadays. Yep. Linear algebra in high school, yep, doable. University, calc and linear algebra within the same course. Yeah, let's go. I mean, I've heard of that, and they seem so separate to me, but you could do that, I think, and it would make sense. Um, like, I don't think we should be learning integration or antiderivatives in high school. I think we should save that for college. Like, you should do, like, the basics, maybe, just so you get to the fundamental theorem of calculus, really. You should just do the basics, but you shouldn't be doing this integration B stuff, like partial fraction decomposition and, like, just all this, like, applied... I don't know. This isn't a very well-formed thought. I think a lot of Calc 2 should not be taught in high school. Calc 1 should be taught. But Calc 1 plus linear algebra, like, just the basics of linear algebra. I think vector spaces. I think that we should teach vector spaces, like, at the end of high school linear algebra. Yeah, game theory would be sick. I came with Silicon Valley experience. Silicon, yeah. Silicon Valley. Yeah, dude. I mean, for real. Like, I wasn't good enough to cut it in, like, research math, and I decided not to go to graduate school. At least that's my opinion at the time. I had imposter syndrome, whatever. But in any case, I really loved the iPhone in 2012, and I was like, this thing is going to change the world. I want to build apps for this thing. All these indie apps are so cool. Somebody built a flashlight. Like, what a hack. You can use the camera flash to get around at night. Like, somebody built an app that, like, hacks the flashlight on your camera, or, like, the flash to be used as a flashlight. Indie apps were just so cool in that 2007 to 2012 period. That's exactly when I was in college, and I wanted to work on iOS apps. And now tech is just horrible. And yeah, it was mutual. Yeah, it was a mutual separation, very much. No joke. I'm not joking with you all. The night before, my very last meeting at Google was with my skip manager, my manager's manager. I called a meeting with him and I was like, hey, I've heard rumors that layoffs might happen. Like, pick me. I would take that. I would take that severance package. Like, I want to do my own thing. Like, I want to, try entrepreneurship and build my own thing. Like, pick me. Like, my coworkers are awesome. Like, if I can get a severance package and they, don't get hit by layoffs, but I do, I think that would be amazing. I'm not joking. I actually called that meeting, and it was after hours, 5:30 p.m., with my skip manager. He was like, no, I haven't heard anything about that. That's not going to happen. Don't worry. And you would not get hit. I'm like, no, I'm serious. Please pick me. Like, I'm volunteering it if it happens. And then the next morning, his manager, and everybody below them, we all got hit. Like, a giant chunk of the org chart. So nobody cares about that. But I was over the moon. It was mutual. It was actually literally mutual. I was like, okay, sick. Like, I'm kind of tired of big tech. What's the name of the cat? The cat is named Luna. We just need one more like. So I'm going to do 10 push-ups right now. Dang, I know, right? There's a lot of lore here. There's a lot of lore. But I promise you, we will be doing frickin' actual real math in a second. Let's get some math on screen. I owe you all 10 push-ups. Now I owe you 20 push-ups. Thank you. Oh, God, dude. Oh, dude, I don't do these enough. The thing is, the last ones were wimpy. The last ones were wimpy, but they were less wimpy than a couple days ago. And I don't think we've hit 90 yet on these streams. So it's been years since I've done 80 push-ups in a single day. And I feel good that I just did 20, and only like the last two were like, they were wimpy, but they weren't nearly as wimpy as a couple days ago. So let's do it, dude. Cute cat, ominous cat, bro just laid on the floor. We know that. I'm not a good actor. Like, I can't do that. You mean the cat back there? Can you see her? Yeah, she's so cute. Her name is Kaya. Oh, Kaya. Kaya. Or are you talking about the cat in the videos? Yeah, yeah. Yeah, yeah. Yeah, yeah. Yeah, yeah. Oh, the other cat is on my backpack over here on the floor. Oh, dude, I'm getting tired, dude. Hey, Leroy, what's up? You're still here. I just made a refrigerator magnet of my cat at Walgreens. Nice. I should do that. I have something kind of like that. Hey, Divya. Welcome back, dude. Welcome back. Hi. Bro, I haven't done 80 push-ups in years in a single day, but it's feeling good. It's like they're getting wimpy at the end, but they're less wimpy than a couple days ago. I'm going to be feeling this tomorrow. Thank you for keeping me off of TikTok and doing push-ups instead of TikTok. Let's go. Let's do something else. All right. So I'm finally caught up on chat. Let's do some math again. While Hawaii is up, I am not reading chat. So you all can chat amongst yourselves or do whatever you want. Oh, one last thing. On Twitch. Ooh, you can't even define sine and cosine without calculus. I don't know. No, I think you can. Sine and cosine predate calculus, very much. What's up, pie in the sky? Good to see you. My primary channel is YouTube, and that's where the party really is. There's like 30 people there, and there's one person in Twitch. So watch wherever you prefer, y'all. Okay. While Hawaii is up, I'm not reading chat. I'm actually trying to learn something and prepare my lecture for today. Okay, so Lang talks about these examples and counterexamples. These are cool examples. He's like pulling from the different branches of math in this book. So example, if two lines are perpendicular, then they have a point in common. Yes. If two lines are perpendicular, they have a point in common. Let's see. Let's use a higher contrast color. But if two lines have a point in common, then they are perpendicular is false. Right? So if I say that line A is perpendicular to line B, then they have a point in common. In other words, they intersect. That's another definition for what, that's the definition for what the word intersection means. So I'm going to use shorthand. A perpendicular to B implies that they intersect, but the fact that they intersect does not imply that they are perpendicular. So this is not, perpendicularity or orthogonality is not equivalent to intersection. And this isn't obvious. This seems like a well, duh kind of thing, but it's for a good reason here. It's because we want to give these clear counterexamples. So then the next statement, well, he also says, example, two circles are congruent if and only if they have the same radius. This is true. Then he says, we often give proofs by what is called the method of contradiction. Okay, I thought he would give counterexamples, but I would teach counterexamples next. But he gives, this isn't an example, this is more like theory that he gives. It's not quite a definition, but it should be some sort of boxed fact, I think. This is a proof strategy, I'll say. Contradiction. And I'm going to give a little extra flavor here. Classically, reductio ad absurdum. And I also like to explain this. I think, therefore, I am. Okay, we've all heard that phrase. It is closely related to this proof by contradiction idea. If I imagine that I don't exist, that's absurd. It's absurd to think that I don't exist. It's impossible. It's a contradiction because I'm thinking the fact that I don't exist, right? So that is a proof by contradiction by Descartes, the same guy who invented Cartesian geometry. Descartes in the 1600s, I think. 1700s? I think 1600s. 1600s, yeah, hell yeah. In the 1600s, Descartes has this beautiful philosophical work, and you should read it someday. I think, therefore, I am. He tries to mathematically prove the existence of the entire world and mathematically prove the existence of God and some other things, but he uses the method of mathematical deduction by contradiction. You imagine that it's possible that a demon is controlling your thoughts, so therefore your analytical reasoning skills are flawed. You imagine that you're dreaming within a dream, that you might be dreaming, so you can't necessarily trust your senses. Like, I've previously had very vivid dreams before. I've even dreamed that I'm dreaming. That's happened before. So just the fact that I have dreams doesn't imply that I'm not currently dreaming. Therefore, I can't trust, I don't have a mathematical proof that there is actually a coffee cup right here in my hand. Just because I feel it and because I can see it, that's not a mathematical proof that it exists, because what that relies on is that you can trust your senses. But I've dreamed that I've drank coffee before, but I wasn't actually drinking coffee, right? Like, this is a crazy thought. This is actually a really wild, interesting thought that kind of is part of the Renaissance, historically. But this is reductio ad absurdum. Like, I don't see a flaw in that argument, so let's keep going simpler and let's find some axioms, something that we just have to take on assumption. I'm going to claim I don't exist. I don't even exist. That's like the most fundamental thing. I don't exist. Let's assume I don't exist. But I'm thinking that I don't exist. For me to imagine that I don't exist requires me to think that I'm not existing. Therefore, I exist because I'm making that claim. I'm imagining that I don't exist. So therefore, we just arrived at a contradiction. And to Descartes, this was the mathematical bedrock, the simplest axiom that he tried to build the entire world and humanity from. You start from logical, the simplest assumptions you can, and then use mathematical reasoning to make bigger claims. And, this is a really interesting argument, and it holds. Some people have tried to take this further, and maybe I think therefore something is happening, but it doesn't matter. The point is, in a mathematical argument by contradiction, if you want to prove A implies B, what you do is you assume A and not B. Or, in other words, maybe we say, let's imagine that A is true and B is false. Okay? Let's just imagine for a second. Imagine that A is true and B is false. Then, so we have if this, then, and then we end up getting to something like then 0 equals 1 or something. You get to some statement C equals true, but we know maybe C must be true, but we know that that's false, or vice versa. C is false, but we know that some result should be true. We know that this is absurd, is what I'm trying to get at. This is absurd. So, therefore, we can walk back and say all of these were mathematically sound. Every step here was correct. Maybe I'll give there's nothing wrong in these steps. I double check all my work and I go back, and then I go back and say, okay, well then either A isn't true or B is, or this was our only assumption. This was our only assumption. So therefore, our one assumption in this argument, assuming that we fix that A is true, the only added assumption that we've added here is that B is false. This also requires the fact that either B is true or false. B must be one or the other. So if we assumed that, if we tried to see what happens if it's false, and then we get a contradiction, then that one assumption isn't the right one. It must be the other. B must be true. This is the strategy. This is the proof strategy of proof by contradiction. It is truly, I think, therefore I am. We've all heard that, but very few, I don't think anybody I've ever met has known that that is a philosophical argument from Rene Descartes and that you can read it today and it's really interesting. I don't think I've ever met somebody who has known that. Like, I mean, I don't interact with that many philosophers. All the philosophy people I know learned it in the same class or set of classes. So I don't think we teach enough philosophy, like, of these classic arguments from the freaking Renaissance. This is proof by contradiction. And I bet that there's mathematicians in the chat right now who have never heard this and never seen a presentation on proof by contradiction quite like this. I think that this is a unique intro to contradiction. So Lang then gives a very perfect example here that in the book, if you've read it up till now, a classic example for this is that square root of 2 must be irrational. We haven't gotten to defining the square root of 2 in our course yet, but I know that most people watching these videos have heard that the square root of 2 is irrational, and you prove it, or no, sorry, you believe it, and you're told that it's irrational because it has a decimal expansion that never repeats. And that seems like a good enough definition of irrational, but then an annoying kid can be like, but why? Why do we know that the decimal never repeats? That is the real question, and we can prove it by contradiction. So an exercise to you all would be to try to figure this out on your own. Here's a hint. Use the method of contradiction. Try your hardest. Set a 10-minute timer. Don't spend more than 10 minutes because it's a clever argument. But this is the classic example of this is the first example in every book, I think, on an example of a proof by contradiction. So what would this proof look like? It would be assume square root of 2 is not irrational. Assume otherwise. Assume square root of 2 is not irrational. And then, ... That's just silly, dude. That's just silly. Like, you end up getting something that's absurd. You should get to a contradiction. So then our one assumption is false. Try it yourself. Do it for 10 minutes. It's better than TikTok before you read the classic proof. This is like the classic argument for it, for classic example. Yeah, this is all going to be too much to fit in one video. So I'm going to have to make decisions. Oh, dang it, dude. Because circling back for those who weren't here at the beginning of the stream, of course, I'm imagining filming my next episode 6, and I wanted to do all 3 of these. And I think I can. I think I'm just going to need to leave some of the examples to the next video. I think I can still do it. But this is where now this course is going to be getting just like a little more interesting for a lot of people, I think. Or at least it's something new. And you can skip these 2 videos if you want to, but for some people this is going to be really, really cool. And then for other people it may not excite them as much, and that's okay. We'll be back to our regular stuff next week. Okay, so let me read chat. I think that was a good little... What? All right, let's see. Let me catch up with chat. Academic mathematicians are degenerates. Yeah, that's me, dude. That's me. That's what I trained in. Okay, let's go. I don't have to do more push-ups. Thank you for giving me a break. Doing physics today. Bye, guys. Take care, dude. Enjoy your physics. You can't define sine / cosine without calculus. Really? Oh, okay. You can define a discrete sine and cosine. I see. But if you want to think of sine and cosine as a function on the real numbers, you definitely need calculus. But you can define discrete sine and cosine on right triangles. So, yes. I mean, that's where my mind immediately went to. Like, no, we define sine and cosine on right triangles, on Pythagorean theorem and the ratio of legs of a triangle. You don't need calculus for that. That's like a classic Greek math pre-calculus. But if you want to say that sine and cosine are defined on the real numbers, pretty much anything you do on the real numbers requires calculus, right? So I think that that's what you are referring to. This is the problem of defining angle measurement. So with calculus, and more specifically with real analysis, you can define sine x as a function of a real number without reference to geometry. Yeah, right. So I think I was just seeing the same approach that you're thinking of. If you want to think of it as a function on real numbers, yes. But you can define sine and cosine in a valuable way that still is valuable to talk about the size of an angle on integer right triangles. On like Pythagorean theorem, the Pythagoreans, who were funny, weird people, like really weird, funny philosophers, they were essentially a cult, which is really interesting. You can define the size of an angle based on the ratio of sides of a right triangle with integer legs. And I don't know enough about the history of math to understand whether or not, or to say whether or not we used sine and cosine, or whether or not there's a term for discrete sine and cosine as opposed to continuous sine and cosine. But yeah, you would definitely need calculus for anything continuous. Anything defined on the real numbers requires calculus. Sure. Agreed. Yeah, in ancient times, sine, like pi, was calculated by geometric approximations before Taylor series were introduced. Exactly. So Arad is thinking along my lines that, yeah, there was a geometric definition of trig functions before Taylor series, like the Taylor series definition of, you know, sine and cosine on real numbers. Yeah. Descartes' argument gets very sloppy very quick, not gonna lie. It's true. It's true. Yeah, like, yeah, in a philosophy class, you analyze where his argument falls apart, but that one idea has stuck. His argument, I think that core hyperbolic, what is the word again? Hyperbolic assumptions, hyperbolic doubt, it's something like that. Hyperbolic doubt or something. Like, we can pretend, like, let's come up with the most absurd ideas, but it's still possible that a demon is controlling my thoughts and I can't even trust analytical reasoning. It's possible that we live in the Matrix, that we live in a dream within a dream, right? Okay, is it possible that I don't exist? No. I can say with certainty, with a logical argument, that I must exist in some sense because I'm thinking right now that I don't exist. That, the beginnings of his meditations, that hyperbolic doubt landing on some fundamental assumption, that still holds water to this date. You know, and it's still a really clever, good argument that we teach in classrooms. There are philosophers who have taken it further, but the basic idea still holds. Sup, boys? How's it going? Craze bye. How are you? Baha'i. Reductium Leviosa. Okay, that's good. All right, I also invented that idea. Reductium Leviosa. Where is this? Where is it? Where is it? Oh, shoot. Where's my proof of contradiction part? Was I working in like... here, we're all the way down here, aren't we? Assumption. Reductio ad absurdum. Reductio Leviosa. That's funny. Reductio Leviosa. I'm going to use that in the future. Thank you, Arad. Also known as me. I came up with that one. That's really good. There is no rational whose square is 2. Yep. Yep. Exactly. Without referencing real numbers at all. Yep, exactly. Yep. Hey, you're already giving away the answer. Ming, you're not supposed to... I'm trying to give people an opportunity to try it on their own, dude. This is rare. Like, when I was in college and I learned in lecture, proof by contradiction, here you go, here's an example, and they immediately give the example, and I never had that opportunity to try on my own to make up an example of a proof by contradiction. I never tried to find the classic argument of what does it mean to say that square root of 2 is irrational, but you are laying it out, and that's fine. That's okay. What does it mean to assume square root of 2 is not irrational? That means assume square root of 2 is rational. Then, ... What does it mean for something to be rational? You need to look up the definitions. We haven't even done that yet. We haven't even talked about rational numbers. But you can look that up. You can try it. So I am going to include this as a little exercise in my video today, I think. And don't spend more than 10 minutes. It's not a tricky, or it's not an obvious thing. You probably won't get it. Maybe you will, maybe you won't. But try it for 10 minutes. And if you want to try it for another 10 minutes, be my guest. but you can at least engage with the idea and try it on your own before you see somebody else tell you all the details. And that's a method of working that I didn't learn when I was in undergrad. But yeah. Yeah, I know most people maybe in the chat right now have already seen this one, but people who are watching my main series of blue thumbnail videos, I think a lot of people have not seen this one. And I look forward to giving them that opportunity to try to read it on their own. Yep. I mean, I know the argument. You don't need to tell me the argument, but the key to the proof is this: discrete math is cooking you hard. You're sure. Norman Waldberger has some rational trig somewhere. Haven't heard of it. Spivak's calculus. I haven't read it at all. I mean, everybody talks about that one. I look forward to reading it sometime. Hey, what's up, philosophies? We're very philosophical today, truly. Any reference lecture to watch along while going through this book? While going along through my videos. I'm trying to make the videos for this book. Nobody, as far as I know, there's no good lecture series on this book. I mean, please let me know what you think. If they're not good enough, let me know. mathcanbeahobby.com. This is my playlist of lectures on Lang's basic mathematics. Not the live streams. These are just hanging out and office hours. There's like a series of blue thumbnail videos, and I've filmed 6 of them so far in introduction and episodes 1 through 5. Episodes 0 through 5 available now. 6, 7 this week. Let me catch up. Hey, yeah. Philosophies, please, if you want to do private lessons, I am available, dude, at Philosophies. Email me, jcpractices@gmail.com for one-on-one private lessons. Dude, I'm pretty cheap for a U.S. teacher with my kind of experience. Promise you. Email me if you want to talk about private tutoring. I'd be happy to talk about private tutoring. Reference lectures. I'm about to film episode 6 here. You're going to watch me film it, I hope. You have a math test tomorrow. Help me. Email me. I would be happy to do some private tutoring if you want to, if you're serious about it. Happy to. Yeah, no, don't be sorry. Not at all. Don't worry. Everybody here, like, this is not the main lecture series. It's all good. You're totally fine. I'm not going to do the proof live. This is unusual, I think. Like, I wouldn't expect you, Ming, to watch these lecture videos because this math, right? Like, you know this math, and they're like 40-minute proper lectures on this. You know all this math, you know, proof strategies and things. But I am trying to design these in a way that's like very interactive and trying to use YouTube and the medium of YouTube to its advantage. Like, people can pause the videos. I can like use the comment section for people to try and answer, and I respond to their solution or something in the comment section. But like, different than other traditional lectures, I'm going to say, try it on your own. Try this one and then read the book. Dude, like, you don't need me to just rewrite the exact same argument from the book. We're all adults here. We're all adults. It doesn't make sense for me to just rewrite the exact same argument. Try it on your own, and when you get stuck, read it in the book. and I'll probably work it in the next video too. If you want to just wait for my video, you can wait for it, but I'm going to give people an opportunity to try these things on their own first, especially because there's no deadlines, there's no time limit. Like, I'm not prepping people to take the Putnam or to get into Harvard or something, or like, you know what I mean, like to take the SAT test or pass a final exam at the end of the semester. Like, we can take our time on this stuff. And so I'm trying to explore that idea, like with a lot more time and the ability to take things slower as a hobby. Like, what would change? What would change in the lectures of Intro to Proofs if you don't have final exams and entrance exams, graduate school applications, all of those sorts of things. Grades, like there's no grades, there's no homework. Yeah. All good, all good. Yeah, I don't know who Philosophies is talking about. I don't work for free. So if somebody wants one-on-one help, I'm happy to, but that's a paid thing. That's tutoring. Math is literally philosophy though. Like, philosophy is everything ultimately. Ultimately everything is applied philosophy. The first offshoot, the first branch from philosophy is math. They're the closest ones, I think. If you call logic philosophy, logic and math, like the connecting edge between the two is logic, and it's this like cross-disciplinary field. But I still go over fundamentals still. Well, heck yeah, I would really like your thoughts and your feedback on pedagogy on these videos if you want to watch them, because like I can engage with mathematicians and math teachers on a different level in the comment section. Like, how was this? This is my first ever lecture ever, and 60,000 people have watched me prove Gauss's proof of the sum of integers. 60,000 plus people have seen my first ever math lecture. It's like a little nerve-wracking. Like, it's kind of like, what the hell? Oh God, there's a lot more people following this series than I was planning for. So yeah, if you want to watch the lectures and let me know how you think, what's going well, what could go better. There's multiple ways. You can DM me in Discord. There's like an anonymous form, feedback.jcpractices.com. I always like to reference that. If anybody ever has anonymous or not, you can choose whether or not to leave your email and contact info. Feedback is a gift. I love and thrive, I think, on feedback. Because I don't know if I'm doing things right or wrong unless I get feedback. And it's just a difficult thing about lecturing to a camera, not being able to like respond to how a student is confused or not confused and ask questions. So it's partly why I really like live streaming. I can ask you all and we can have a two-way conversation during the thing. Where's the star of the show? She's sleeping over here. She's sleeping on my backpack. Where's the other star? Oh, the other one left. Yeah, she's taking a nap right now. I need help with education, but the thing is, you can't really afford your course either, even if you think it's cheap. Not for me. Yeah, I feel you. Just want to talk about education and stuff and help I need. Okay, so the other option, I do want to be offering free access to education. So that's where the lectures are. The lectures are. Please drop a comment in the lectures about the kind of math that you want help with, and I might choose one of those topics in my future lectures. There's also my Discord, as well as other people's Discords. But in this one, you can go to, like, if you're studying this book, you can go to study group. There's a channel called Study Group for basic math. There's a study group channel there. There's just the general purpose math channel. There's even a special channel for math exams, which a lot of people are want help with. So you can meet other students and you all can help each other and study together. There's also a voice chat channel, Study Room. So if you want to pop in there and say and tell people, hey, I'm in the study room, I'm working on vectors or something, or I'm working on integration today, you can use the voice chat channel. I'm probably not going to join just to set expectations, but you can meet other students and you can help each other, or you can meet other teachers who want to volunteer and help. But I don't work one-on-one advice for free. Sorry, I just don't have time for it right now. I wish I could, but I just don't at the moment. So those are some options for you. And still find holes in my own knowledge. Yeah, all of us do. That's why it's so valuable to reset back to foundations. And Lang even said that part of his motivation for writing this book was to revisit the fundamentals and like the real foundations and try his hand at like if he could run a high school classroom the way that he wants to, how would he write the textbook for his dream high school classroom? Which, yeah, it's a nice book. It's just a nice book. So, let me know, what do you think? How does that sound, y'all? Like, I hope it doesn't sound like I'm an asshole and I just want money or something. It's just, I'm unemployed. I'm trying to get a job. I don't have time to, like, my goal is to be focusing on this, which can help a lot of people out there. A lot of people are looking for this topic and this lecture series. And I think that this can be a good portfolio piece for me as I'm applying to in-person jobs and running a classroom. There's no better way to solidify your knowledge than to teach. He says that in this book. It's really great. In this chapter that we're talking about, let me just read this out loud. The very last paragraph of this section that I'm introducing this week. In any book, it is impossible to avoid some mistakes, some confusion, some incorrectness of language, and some misuse of notation. If you find any such things in the present book, then correct them or improve them for yourself, or write your own book. This is still the best way to learn a subject, aside from teaching it. That's he just like leaves that as the last sentence of that chapter. He's like, if you find mistakes, write your own damn book. It's great. Isn't it really funny? Like, if you find a mistake, just write your own book. If you don't like my book, write your own. And it's true. Like, it is the best way to learn a subject is teaching. Like, it's super, super true. And that's why I'm spending my limited, valuable time trying to teach. So, yeah. Okay, so philosophies, let me give you one pro tip. Let me give you one pro tip that has been hard-earned for me that I learned in the workplace. It's an isomorphic problem here. It is an isomorphic, it is the same exact problem. KnowHello.com. Please, everybody, go to this website, please. I'm very tempted to just pull it up on stream. I will do that. You know what? We're going to do that. KnowHello.com. Give me a second. It's so similar. It's similar but different. It's very adjacent. Okay. You should be able to see this. Don't just say hello in chat. If you're in the workplace and you're working in Slack and you want to talk about if you have a question for your coworker or something, don't just say hello. Don't ever just DM somebody. Please don't just say hello in chat. Like imagine that you're in Slack, you're at work, and you just text somebody, hi. What's your coworker gonna say? Hello. Coworker waits while you phrase your question. All right, so you just say hi, your coworker says hello back 3 seconds later, and then 2 minutes later, your coworker is waiting while you are writing your question. And then 2 minutes later, you say, I'm working on something and I'm trying to do, etc. Right? I'm working on this thing and I'm trying to do this. And then your coworker takes 30 seconds to answer. Oh, that's ... It's as if you called someone on the phone and said hi and then put them on hold. Like you call someone on the phone, you say hi, and then now they're on hold and they're listening to hold music. Please just do this instead. Hi, hyphen, I'm working on something and I'm trying to do, etc. Coworker answers question. There wasn't this 2 minute gap when you said hi, the coworker says hello, your coworker is stuck, you interrupted them, and now your coworker is waiting for 2 minutes. They're like, okay, this person needs my help. I'm gonna have to take a break. I'll maybe make a coffee or something. And then you ask your thing. Why didn't you just write the question first with the hi? Okay, so now note that you can get help minutes sooner and you don't make them wait. Instead, the coworker can start thinking about your question right away. This is not an obvious thing. This is a common mistake in the workplace. And we would, lovingly, truly, kindly send people this website, especially at Google. It was part of the culture. Of like, oh, just kindly, like in the future, next time, just ask the question. Just ask the question in the first message. You don't need to be, I'm not going to see it as rude if you just ask the question while you say hi. I would rather you do that. You get help minutes sooner. You don't make them wait. Instead, the coworker can start thinking about your question right away. You're trying to be polite by not jumping right into the request like you would do in person or on the phone. But chat is neither of those things. Typing is much slower than talking. Instead of being polite, you are just making the other person wait for you to phrase your question, which is lost productivity. So I'm not trying to be an asshole or anything. I'm not upset in any way about this. I'm just trying to give you one bit of free advice, free tutoring. This is free tutoring. It's more valuable than whatever math question you have right now. I'm telling you. The same goes for hello, are you there? Or hi, Bob, quick question. Or do you have a sec? White tea and ping. Just ask the question. If you feel it's brusque to simply say hi and ask the question, you can do something like this. Hi, if you're not busy, I was wondering if I could ask a question. I'm working on this and I'm trying to do that. Additionally, ads, dude, I don't like ads. Additionally, asking your question before getting a reply allows asynchronous communication. This is a big one. If the other party is away and you leave before they come back, they can still answer your question instead of just staring at a hello and wondering what they missed. Short link to this page. Go to this website, everybody. Share it with everybody. If you see that as someone's status, please be prepared to be ignored if you only say hello. This is such a wonderful website, and I love the opportunity to talk about this because this is not mathematics, but it's so related. It's just so similar. So if you have a question about something, drop your question in chat. You don't have to ask permission. It's very related to the idea of ask forgiveness, not permission as well. So Nohello.com is related. Another, ask forgiveness. Not permission. If you have a question, just ask the question. And don't ask the question of whether you can ask a question. That's the part where I'm trying to emphasize. If you told us in the first message, hi, I have a question. Could you help me with integration? Or could you help me with, somebody asked me a couple days ago, machine learning or optimization theory or something. Then I can immediately answer and say, no, sorry, we're focused on basic math, and I also don't know anything about information theory, or I don't know anything about studying for the JEE or something. But I still don't know what kind of math you were wanting to ask, and now we've just spent some time on it. So I just kindly, I'm not upset in any way. It's just that this is a pro tip, and this is going to make you money in the future. The sooner you learn this, this is a tip that, is just very valuable to the workforce. So hope you enjoyed it. Yeah, dude, I'll apply this method with my parents. I don't know what that means. The other thing is ask forgiveness, not permission. Just go for it. Ask whatever question you want. You don't have to ask me if you can send a message in chat. Now, if you send a message in chat and it's horrible, I'll just ban you. But it's not like if you ask permission and then I say yes and then you say something horrible, I'm going to ban you there too. Just do it. Just ask your question or say your thing, and then either I'll answer it or I'll say, sorry, can't answer that, or sorry, not today, maybe tomorrow, or I'll ban you. But don't ask if you can ask. That's, dude, pro tip right there. Okay, so permission to speak granted. Exactly. Yeah. We don't need permission. What a wild website. Very useful, though. Yo, dude, seriously, in Stucky, this is a great website. This is the most valuable thing you all are learning today. Forget all the math. This is the most useful thing that you've learned today. The math is fun, but this one is actually something that'll earn you some money. Okay, so I'm trying to catch up. Okay, so I'm not going to email you. You can email me if you want private tutoring. I set the boundaries, and then the thing is that if you ask oh, I need some help with partial differential equations, can you help me? I would immediately say, no, because we are only doing basic math. Also, I don't know anything about PDEs. But then Ming is in chat, and he could have immediately been yeah, I'm going to talk about PDEs in my stream tomorrow. And then you'd be oh, sick. So all of this could be more efficient. So, there are other people. To add back to your original question, no, I'm not giving out free tutoring, but you can find free resources. I'm still offering lots of free resources for people who want to study together, or you can find somebody else who's a student learning the same exact thing, and then you two can link up and become buddies and study together in the Discord or over email. I don't care, in this chat box, whatever. You all are allowed to talk about anything you want to in this chat box. I don't care. So if you want to ask questions about PDEs and somebody else answers questions about PDEs here, that's fine too. Okay. Okay, wannabe polymath. Hey, I love your name. That's a great name. Return to math after 31 years. Oh, dude, are you the person who left... Bro, Life of Journo, are you the person who left a comment that's one of the most top voted comments on episode 0 of my series? I feel like I recognize your profile picture. There was somebody who also was returning after like 30 years, and their comment was one of the top comments. Um, Dude, and see, look at this. Like, in all this, I just gave so much free info. I just gave away so much of my time for free, and this person didn't even respond. Dude, like, some people just want free shit on YouTube. Like, I'm not here to just give away free math tutoring, dude. Um, Dude, okay. It's nice to meet you all. I really do want to hear your follow up on, like, what kind of math are you looking for? Like, what? I don't know. This is just, like, the most nohello.com moment. Okay. Return to math after 31 years. Never bad at math. Never liked it. Yeah, I know the feeling, dude. And you've been a sports journalist. Yeah, yeah, the sports journalist person. Dude, nice to meet you. Thanks for making it to a live stream. The live streams are totally different. This is not the series, dude. I'm sorry. We've been going for almost 4 hours now, just ranting, talking about math and hanging out, and we've been pretty mathematical. I'm putting away chat and working math, taking notes and preparing my next lecture, episode 6. But the live streams are totally different than the book, so just warning about that. Math gives me a mental breakdown. I'm sorry that you feel that way. It sucks. That is a thing. Yeah. If it gives you a mental breakdown, maybe you should study something else instead. First time listening. I appreciate your math series. Hopefully we'll start watching. Awesome, dude. It's nice to meet you. Thank you for being here, Abdu. I still can't believe that in just the last 3 months, I've been able to understand concepts like inequalities, straight lines, and functions. Calculus is next. Let's go, dude. That's awesome. Slow down. Life of Journo, slow down, slow your roll. I'm going to show you a lot of really cool math here. If you feel like this book and my videos are moving too slow, get this book. Get number theory. Get freaking this one. This is just like a more standard college level version of this book. How to prove it. Get this book and do this instead of calculus. Or if this doesn't look interesting, get this book, Abstract Algebra, bro. Like, you can find all these PDFs online too. Like, it's not hard to find a PDF of a math book. But if you can get a paper copy, I've got affiliate links, and the library has paper copies, and just paper is the best way to learn any subject. It really, really is. But what I'm saying is there's so much more beautiful math that's better for your brain, I think. There's just other types of math than calculus. And if you think that if these videos are moving too slow, just get this one. This is the same stuff, but it's harder. It's just harder, a little more mature. And if this is still too easy, dude, I got plenty of harder recommendations, but it's the same exact topics in more depth, in more maturity, in more depth, harder. This is just, yeah. Like, dude, learn number theory. Don't learn calculus. I want everybody to learn number theory, not calculus. What do you think of people who learn machine learning? Those who use libraries or write their own code from scratch, but only focus on the fundamental concepts. In your experience, which is the best? I can't say anything about that. Like, if you're really building apps, you should be using other people's software, but you also should understand what those packages are doing, and in theory build it yourself. But realistically, you don't want to build everything from scratch. As a software engineer, we were careful about which dependencies we would take, and it would need a very good argument about why we should add this dependency. Like, it was reviewed by a lot of smart people. Somebody's like, I think we need to use this library. And then you'd get a whole freaking committee of people to review that argument before you take on a dependency. Yeah. So, I don't know. I've never worked in machine learning, but I think it's the exact same thing. A lot of people want to learn math now for machine learning. I don't know. I mean, I think it is valuable to know the math behind it, but in the day-to-day, I don't know if you're actually going to be using linear algebra. Um, yeah. 26 years old, I feel a big discrepancy between diving deep into math and science, which I really love, and making money to live. Any advice? I feel like I have to choose. I say, Abdu, personally, my path has been learn math, but also, and like prioritize, and if you can, prioritize those raw fundamental skills like math, but also learn a little bit of a valuable skill, something that people actually have jobs in that you get paid for. Nobody is asking for a pure mathematician. Sorry, that's just a fact. There are no jobs looking for a pure mathematician other than being a mathematician, like being a researcher. But like other than being a researcher, that's the only job out there looking for a pure mathematician. Everybody else is looking to use your mathematical training to solve a real world problem of one kind or another. Like nobody out there is getting paid to add the Fibonacci numbers by hand or try to prove the Collat's conjecture unless you're an academic. Nobody in industry. There's no industry job looking for that. You could learn to teach and become and work on becoming a high school math teacher, but that's different. That's a different skill. Like it's adjacent. It's so related. Teaching high school math is a related skill to learning math and doing math, but you have to learn things like behavior management. Like how do you handle a class of immature kids? Like that's a different skill than math. So learn math and prioritize it at this point of your life when you can, before you have responsibilities and things like that, if you can. But also at the same time develop enough skill in something valuable that you can have a job on the other end. If along the way you think you want to be a mathematician, it's a hard path, but you'll know it because you tried math and prioritized that. I don't know. I don't think that you're going to be losing out in any way because you did a minor in something applicable like computer science or something. Like I think everybody who's studying math, like pure math, should also be getting a minor in something applied. But that's I don't know, that's going to ruffle some feathers. That's going to make some people mad, I think. But it's just like, it's probably not a good idea. It's not a good economic idea to study performance music, to be a performance major learning classical guitar as a performance major. That's kind of dumb. That's kind of ridiculous. Like nobody's looking for that other than teaching, kind of, but there's so many teachers out there. But you can do that and computer science, or you can do that and music education. You can learn education too, and then you have something that there are actual jobs in. Now, if you want to make a counter argument, you can argue that AI is going to take all jobs and therefore just do whatever you want. But that's a different argument. Nobody really knows. I have a target to qualify for the IIT Madras BS Data Science program. Wow. In retirement, right? Life of Journo. Bro, are you trying to get into IIT or just qualify for IIT in retirement? Dude, that is so sick. You said 30 years ago, right? I mean, maybe you're not retired. But you've been a sports journalist for the last 21 years. Like, as a second career, you want to go to IIT? Bro, that's awesome. Like, mad respect. That is really cool. That's honestly inspiring. Like, your comment in that video was one of the most inspiring comments to me, dude. Like, yeah, it's nice to meet you. It's great to have you here in chat. I hope you're enjoying it. We really need the Node.js package for padding strings. Exactly. Like, there are people who are like, we need the is even function. We need to depend on the is even module just in case we didn't consider all of the corner cases of whether or not a number is even or not. Yeah. Master's degree in physics in Germany. Been looking for a job for 4 months. The market is really hard in general right now, dude. I just think you're not going to regret studying something hardcore and foundational like math or physics. Like a foundational STEM field, I don't think you're going to regret it as long as you also study something that you can pair it with that there are jobs in. If you can do a minor in economics or math, in economics or education or frickin' computer programming, engineering, law or something, I don't know. Get a minor in something valuable and pursue math as like this art field that's also very valuable and transferable. It's kind of a superpower, dude. Yo, thank you for the gift, dude. Thank you, man. Learn discrete math without calculus until you run into generating functions. I don't know what we're talking about there. Yeah, the job market is just really hard. I had filled out my grad school applications and I was going to click submit. I had letters of recommendation. I had all of the background. I know I would have gotten into some, but I don't know. When it was time to click submit, I was just like, no, I don't think that this is my path. I just don't think a PhD is my path. I feel like I would rather go into industry first and then do a PhD later, maybe. Maybe. That was a big maybe for me. Okay, asking because you're considering applying in the US as well this coming year. Okay, and it's an online program. Nice, dude. Thank you for the gift, dude. All right, I'm all caught up in chat. I owe you 10 push-ups, and now we're going to get back to the mathematics. I'll take a break because I haven't eaten anything at all, and this stream has gone super long. But first, here's 10 push-ups. Oh my god, dude. All right. This is insane. I haven't done 90 push-ups in a long time, and I'm surprised that I'm not dying right now. That's really cool. Thank you, everybody. We'll do just a little bit more. I think now is actually just a perfect opportunity. Let's take a break. I'm going to take like a 10, 15, 20-minute break. Something like that. No more than 20 minutes. I'll be back. I'm going to eat some lunch really quick, and then we're going to get back to the math. Thanks. This has been a really fun stream, everybody. Like, just talking about math, I think, is really valuable, as well as working problems. I still think that we really talked about a lot of math stuff and gave career advice and philosophized about math, which we don't do enough of. Dude, we just don't. All right, yeah, let's go. Let's all take a break and touch some grass and eat something and get off of TikTok. Go work some math problems, dude. All right, this is my classical guitar recordings. I'm also a classical guitarist. So y'all, yeah, hey, it's really great to have you in chat, Ming. I'm going to try to catch some of your streams. When do you stream? What's your schedule like, Ming? Please do let us know what your schedule is like. I've given the shout out a couple times, but there's new people here now, so Ming streams. More applied math. Versus pure slash fundamentals, like what I do. So yeah, y'all should follow him if you're not already. He streams. I don't know his schedule yet. I hope he tells us. And what else? I was going to say that these videos that we're watching are from my original channel, OG jcpractices channel, classical guitar, deep hobby. So sometimes I stream there. I'm not doing it as much nowadays, but you're taking a bit of a vacation, so you're going to stream pretty frequently. That's what I thought. I was like, I think he's streaming like every day. But like, what time of day? That's the most important thing. Like, when you stream, what time of day do you typically stream? Okay, sick. Every weekday afternoon, 2 p.m., which time zone? I know, but you gotta EST. Okay, cool. So, in 30 minutes, are you going to stream? In 30 minutes? Dude, that's cool. So that's your typical streaming time. I will try to make it sometimes. Yeah, really great to have you in chat. It was fun. Awesome. All right. Well, I will be back. I'm going to eat some lunch. I'm hungry. Eat and then stream. Nice. I will try to. Oh, dude, Ming. Turn on your ability to redirect. Nobody knows about this. Nobody does this, which is a freaking shame. There's a long story here, but I'm not going to go into it. I used to work at YouTube, and in your channel settings somewhere, you can Google this and find it. Turn on redirect privileges so that I can redirect and raid you, which means when my stream ends, I'll bring anybody who's watching to your stream. So it's like kind of like I like to call it an after party. YouTube calls it a redirect because a freaking engineer named it. But Twitch calls them raids, which is a term from video games. YouTube, we should be calling them after parties. So I will tell people after party at Ming's stream. And if you turn on redirect privs, turn on redirect privileges. Nobody knows about this on YouTube, but it is a very useful feature, and I want YouTube to fix it. They need to delete that entire directory and start over from scratch. It's just so broken. But it could, they just need to do it all over again. It's a critical core part of streaming on Twitch, and it's just nobody uses it at all on YouTube. It's been over a decade, not sure how useful concrete course recommendations are you. Courses, I don't know much. I mean, if you're interested in ML, I don't know, dude. I think you want to ultimately you want to get good at your linear algebra, and you want to get to theoretical linear algebra at some point. I don't know. I don't have recommendations. But I know for machine learning, you want to get really good at linear algebra and probability. You need both of those really hardcore. Linear algebra, probability. Okay. All right. I'm going to take a break and eat some lunch. Bye. Bye, everyone. Back in 20 minutes. Cool. what's up, y'all? I'm back. 4 hour stream today. Could go more. We're at 4. We're almost 5, dude. Locke, why are you rounding down? Who taught you how to round numbers? We're at 4.6 repeating almost. We're at 4 hours, 38 minutes. We're nearly 5 hour stream today. Who said that streams should be 3 hours long or 2 hours long? They can be 10 hours long, dude. I can do a 10-hour stream. I've done them. Heidi can attest to this. Like, I've done 10-hour streams before in classical guitar, nonetheless. Like, which I love. I wasn't even yet mixing classical guitar and math. We could do both, right? Catching stream near the end of my sleep time. Yeah, it could. You're new. You're new here. You're relatively new. I can do long streams. I got nothing better to do. I'm a freaking degenerate, unemployed, person loving, YouTube and getting attention and shit. Well, like, you don't understand how degenerate we can get sometimes. In a good way. Hopefully in a good way. I pressed the wrong button, so let me press this one instead. Now, let's get back to mathematics. So we were trying to prepare my notes, and this has been a long, fun stream. I want to give one more shout out. I don't think he's live right now. If you all want actual math and to learn new, difficult, college, graduate level math, you all should absolutely be following Math with Ming. If you're not already, he's a really fantastic math streamer in this tiny little niche of math. Don't watch me for 5 hours. Watch me for 3 hours, and then watch Ming for 2 hours. So he's live now. If you want to check out what he's doing, he's doing some tensor analysis. But he was hanging out here for 4 hours before his stream. So today was the first time that we really had Ming hanging out in chat. We had a long, fun conversation. This was my favorite moment, and I think Heidi will particularly appreciate this because she knows my life philosophy about deep hobbies and stuff. You might not know this math joke, but Math with Ming says, there exists a partial ordering over the set of all hobbies. And this is when I said that there are some hobbies which are objectively better than others. I think that there's an argument that math is objectively a better hobby than TikTok. And that's a philosophical argument. I can make the counter claim. I could argue the other direction, but if you ask me, personally, I believe the philosophical argument that math is strictly better than TikTok. And then Ming had this follow-up idea that there's a partial ordering over the set of all hobbies. Everything is better than TikTok. There we go. There's my belief in that. What's your proof? Everything is better than TikTok. Every single hobby that you can imagine is better than TikTok. Maybe all the rest of them are tied, but TikTok is the least. TikTok is a minimal element of this post set. Exactly. Locke is on the same train of thought. TikTok is the minimal element, and there's at least one. Math is greater than TikTok, and TikTok is less than math. Therefore, there's a partial ordering over the set of all hobbies. I love it. There's a proof. And then corollary from Christian, don't get a hobby, get a maximal hobby. I like that. And that's making me wonder, is there a least upper bound property of the set of all hobbies? Is there an LUB? What about using TikTok to learn math? Not as good as actually studying math. That's not actually studying freaking math, dude. You cannot learn math on TikTok. You can't learn math on YouTube either. You're learning a little bit of math, but not really. Here, let's just acknowledge that. You're not actually learning math. If you want to learn math, you need a paper notebook. You need to be staring at a blank piece of paper and stuck. No notifications popping up, no cats running around and being cute. You need to be looking at a blank piece of paper and you don't know what to write down next. That is where you really learn math. And that's the joyous moment. You're not going to learn from somebody telling you what the next answer is. And you definitely can't get stuck and stumped in a 30-second TikTok. Dude, like you just can't learn math. If actually doing math is getting stuck and then solving a problem, then you just can't do that in a 30-second frickin' TikTok. Math has too many sweats though, lol. What do you mean by that? I feel like this is like some Gen Z language. Sweats, like it's too difficult. True, but if you don't have a goal, if you don't have a deadline or an exam or college entrance exams and stuff, that's the most fun part. Like the fact that it's hard is the joy of it. That's where I think that this idea that math can be a hobby is resonating with some people. There are people out there who are studying math because it's a fun, difficult hobby, and it's okay if they don't get to world class, right? Oh, math has too many Gausses running around. Yeah, but I mean, I don't know. Gauss was rare. Like Terence Tao is rare. Like there are like the outliers in a thing, but that doesn't mean that you shouldn't study it for fun. You know, hobby maxing. Yeah, that's a good one too. We should get hobby maxing. Heidi gets credit for this one. I mean, for now, but I'm going to steal all of these. I'm going to pretend that this was my idea. Hobby maxing. That's what we're doing over here. Depending on who you ask, either Heidi said this or I said it. From now on, I'm going to claim that it was my idea. JC practices math. Yeah, hobby maxing is a real thing. I love it. That's a good phrase. All right, we need 3 more likes. I'll do 10 push-ups, and I am preparing my lecture for episode 6. And I think this time around, I want to film it live. So y'all will be here for the live filming session. Y'all, I don't know if I've emphasized this enough. I'm so proud, dude, that 200,000 plus video, which is now, like, seriously, that episode 0, obviously the graph looks like this. It jumped and then it's been falling. First off, it's getting a little bounce, actually. It's concave up right now. It's lifting ever so slightly, but it is lifting again, which is sick. That's like, wait a minute. I mean, it's consistent for like 3 days. It started lifting again. I mean, this is not to scale. It's like even more dramatic than that fall off. But I mean, of course, you would expect any viral video to lift a lot, drop a lot. But now what's cool is that this shape is now has a positive derivative, honestly. Like, the slope is going up again. It's, like, increasing now. It's not continuing to fall. It's not a shape that looks like this, where the slope is negative. So that's kind of sick. So, one thing, it's starting to lift again just ever so slightly, but, dude, I fucking did it live, man. Like, this is what I've just been saying for years on my live streams. Like, do it live, dude. Like, you just do it live. Get good enough to be able to do this stuff live and film your videos live. Like, that video was live. And if I wanted, I could go back and I could find my old live stream where I filmed that one. It was a viral 200,000 frickin' video. You know, that's like the area under this curve. This is a bunch of money. I mean, not that much, but at least the area under that curve is a decent amount of money, 200K views, and rising. It doesn't look like it's going to hit 0 and stop being recommended. Like, because of signs like this, that it's actually concave up right now, it looks like YouTube might treat it like an evergreen video, which would be insane. Like, dude, that would be so crazy if it continued even just hovering around like this. That's about 1,000 views a day, like about 1,500 views a day. That's good for me. That's really good for me. Even if it just continues slightly lifting and compounding ever so slightly, I'm feeling very good about the potential there. Um, but my point that is causing me to rant about this is that I freaking did it live, and you only get there by practicing. Like, like it's not like you can just do that out of nowhere. You have to practice that skill, and I practice these sorts of skills on my guitar channel, in my hobby channel. Like, this is still a freaking hobby also, but it's also more of a serious semi-professional slash professional pursuit as well. Like, guitar has been 90% hobby, 10% profession or side income or something. Math is more like 50-50, or 10%, 90%, depending on how all this goes. Yeah, I'm sorry you have to miss the live filming. I know. Fun. Yeah, if the stream goes on for like 7 more hours, I can catch it. Lol, I don't think so. Episode 1 deserves all this. What do you mean episode 1 deserves this? Episode 1 is not bad, man. Ep 1? I don't know if I think I filmed that one privately. But Ep 1, y'all don't realize. Ep 1 is not just my first episode in this YouTube lecture series. This is my first math lecture. Okay? This is my first YouTube math lecture. It is also my first math lecture, period. YouTube or not. And this is now at about 60K plus. Like 60,000 people have watched, or 60,000 times people have stopped by and watched some of my first ever math lecture. That's kind of cool. That's an accomplishment, dude. I'm proud of that. The video with the actual math should get the insane blow up in views. We'll say this has been a godsend on my feed because I'm a physics major with barely any proofs training. See, this is my other thought, is that proof-oriented math has been this kind of esoteric art form, arguably useful, not useful. It's kind of an esoteric art degree, different side of math that you don't really need even, I don't know, even for a lot of physics, until you get to a certain level, and then you need to learn this stuff. But now, more and more people, now proof writing in math and the ability to read higher math, like abstract math, is going up in demand. Like, we need more high quality proof oriented math resources. We have perfect, calculation systems like Khan Academy, but you don't learn proof writing from Khan Academy. Not really. Like, the best resources are still lecture series and things, and we just don't have enough of it, I think. So I've been seeing this coming, like, for years, like, especially as AI is becoming more important and more people want to learn AI to get a technical job because all the Twitter jobs are gone because Elon freaking fired everybody from Twitter. Now all those people from Twitter are trying to find technical jobs working on AI, and that needs math. That needs hella math that technical people didn't need a few years ago. Physics majors have a license to say proof by it works in reality. Yeah, we observed it in the lab. We need high school curriculum to be more proof oriented. I'm insisting that so hard, and I ranted about that for ever today. I'm sorry that you can't be here, Locke, for the live filming of it, but I'll just show you. I've been preparing my notes and thinking about exactly what do I want to talk about. Heidi, Locke, all the people who are like following along this series, check this out. We are going straight from, where is it? I don't know where I wrote it. Man, my Apple Pencil keeps disconnecting. I don't know what's going on with it. It's like as if it's out of batteries, but it's not. Dude, there's something buggy. I think I need to like reboot my iPad or something. Okay, well, we got it. We're jumping straight to chapter 16, the last chapter of this book. We've done chapter 1.1 on the integers. Then we did, not dollar, 1.2 on addition. Then we did section 1.3 on multiplication. Next, we're doing chapter 16 on induction. That's next. Really, technically, we're doing 16 and this interlude. Sections 1 and sections 2. Oh, fucking hell, this iPad pencil. This interlude has 2 sections that I'm going to draw from today. Interlude 1 on reading math, interlude 2 on logic. So the next episodes in this series will be on logic and proof by induction. So we're jumping ahead. And I'm telling you, there's a method to the madness. And Lang actually is encouraging teachers who are building a course out of this book to do exactly this. And I'm following his instructions. Because this is a good idea, I think. Locke, let me know what you think. I feel like I don't even need to fill in the details. You know the logic here. No pun intended. What do you think? Induction looks like a nice next step. Yay, logic, right? See, your reaction is like, oh, good idea, right? That's a good idea. We don't need to introduce fractions. We don't need to learn how to add fractions. We don't need to invent the fractions. We don't need to invent the real numbers. We don't need square root of 2. We don't need geometry or trigonometry or any of that other stuff in order for this to be the next thing. I think it's a good idea, right? Hell yeah. So I'm excited for this because this, I think, is now the first big new moment of new math for a lot of people following this series. Because I think a lot of people, some people may or may not have seen Gauss's proof before of adding numbers, but overall, like everybody has seen addition and multiplication, and it seems like things are, okay, we're doing the math that I remember, but a little more seriously, or like with a little more maturity or something. Now I'm actually, for the first time, I think, introducing a new mathematical concept that people haven't seen before. And that's, I think, very exciting to me about this. Going all the way to R would be a bit of just unmotivated pure math. Yeah, this book is not going to formally build the real numbers. It's going to do the same hand waving that high school classes should, I think. But certainly, I don't know. I'm just looking forward to this lecture video. This is my goal, and so I've been taking notes today on these sections. Last night, I took some notes on induction. I need a bit more time. I'm not ready to just jump into this and film it because I do want to prepare notes. So I'm going to take off the shirt. I'm not ready to film yet. But yeah. So some people are already saying in the comment section that my series seems disorganized, and I'm a little afraid that they're going to say that this seems really disorganized. Why am I going from, we haven't even finished chapter 1, and now we're going to go to the last chapter in the book. We're going to go to chapter 16. But I promise you, this is how college courses are built. This is how, like, a college course in the same topic is structured. Like, week 1 would be induction. Like page 1 on a lot of them. Logic's also a nice interlude to help us look at how our proofs are structured. Yeah, I'm just going to do just like a little light basic introduction to logic and formally define what a deduction is, talk about how we're separating assumptions versus deductions, the structure of if this, then that, A, if and only if, B. Like, we don't need to go much beyond that. It should be the connection between the topics. Yes, dude, I was talking for a long time earlier in the stream about how Lang encourages us to go middle out. And I think that that is absolutely the right freaking way to do this. If you want to learn math, that's the best way. You want to go middle out. Start from the middle, find a topic that you want to learn, go back, read the relevant foundations, the definitions, and learn the statements of things, and then look forward and see applications. And you should be going middle out the whole time. Like, sometimes you'll look back and look at definitions and previous results, and you were planning on just taking that as an assumption, but you do the same thing there. You think, oh, no, actually, this is actually kind of interesting. Let's go this way. Let's actually look at some of the foundations there. I do want to understand the proof of that thing. This is one of the big topics, one of the biggest points that he makes in this interlude chapter. And he says you can read this at any point of the book. You could read it as the very first chapter. We could put it anywhere. So it in the middle is as reasonable as anywhere else. So I've been taking a little bit of notes of like, what do I want to use in my video? Lang doesn't use this one, but like the example of all men are mortal, Socrates is a man, therefore Socrates is mortal. That is a classic example going back all the way to Greek times of an example of a deduction. We assume, just for the sake of argument, assume that all men are mortal. Let's just agree on that for now. Let's assume that Socrates is a man. If we both agree on both of those things, then therefore it must be true that Socrates is mortal. So this is a classic example of a deduction. We take two assumptions and then we have an immediate consequence. This is the structure of mathematical argumentation. The book even introduces contradiction, and in the stream I had a really fun little practice session comparing that to reductio ad absurdum and Descartes' I think therefore I am. I don't know how much I want to use of that in the lecture video, but it was a really fun discussion earlier in stream. And Arad had this, reductio leviosa. That's really funny, dude. That's really funny. I'm gonna claim that for myself. I made that one up. That was me. JCPM. jcpractices math came up with that one. Reductio leviosa. I'm going to use that forever now. So the structure, and if Heidi's still watching, I think that this might be the first time that you're learning this. The structure of a proof by contradiction, if we want to show A implies B, sentence A implies sentence B, we assume that A is true, and we also assume that B is false. Then we have these two assumptions, and our second assumption is that B is false. Then something, then something, then something, then you get to something that's nonsensical, something that's impossible, like 0 equals 1. Something like this is a contradiction. It's absurd. It's impossible. Right? then you need to go back and fix your assumptions. One of these two assumptions must be false. So if we have already shown in the past that A is true, or if we do want to prove that anytime A is true, then B is true, then it's like we're fixing this one as true. If A is fixed to be true, then B is your only assumption, and then therefore B cannot be false. Otherwise, we end up getting something nonsensical, something that just doesn't work. So this relies on something called the law of excluded middle. Every statement is either true or false, and philosophers will argue about that, but classical logic says every mathematical statement is either true or false. And this proof by contradiction, you can prove a statement like this by assuming A is true and B is false, and then finding a absurdity, a contradiction. And this is exactly what I think, therefore I am refers to. Like that very famous saying from Descartes, from René Descartes, the same guy who invented Cartesian geometry in the 1600s. I think, therefore I am. It's the exact same thing. Non-constructive logic mentioned. Yeah, I don't want to go into the details there. But I will say it, that some philosophers will argue about whether or not everything is either true or false, but I'm not going to. Classical mathematics and classical logic, we assume the law of excluded middle. Every statement is either true or false. That this always is true. That a statement is true or not A. Clearly, this first one is A, but A or not A. Everything is either... Yeah, it's impossible for something to be both true and not true at the same time. This is kind of like the cat is dead and alive at the same time. There's sort of like a quantum mechanics moment that happens in the 20th century that challenges some of these assumptions. But for thousands of years, we have always believed everything is either true or false. And for the sake of this course, we're going to work with that, because all of math is built on this. Even though there's some new modern math that tries to prove things without that assumption, but that's a different thing. I don't want to go into detail on that on the course video. This is how you approach learning ring theory for AG and field theory for A and T. Exactly. Like, it is very valuable to learn things in context of more interesting problems. On my Collatz conjecture video, I talk about this all the time. When I'm teaching kids function notation, I don't teach them functions. I say, hey, we need this. Let me just explain it really quick. If you give the number 10 to the machine A, it's going to return 5. If you gave the number 10 to machine B, it's going to return 31, right? Okay, now the interesting thing is no matter what number we choose, Collatz conjecture is going to end up being at 1, so we can start 5, 16, 8, 4, 2, 1, and then we get stuck in a loop. This is the interesting fact that I want to tell you, little kid. I'm not trying to make this the most interesting thing that you've learned today. Like, functions are useful to understand mathematical properties. This is the fun fact. And it is fascinating. It's fascinating to adults, too. It's fascinating to anybody. If you don't know what I'm talking about at all, that's on purpose. I'm not trying to explain it in depth. You can see episode 5. Dude, my pencil is not working. If you don't know what I'm talking about, you can watch episode 5 from my playlist. Episode 5. Math can be a hobby. .com. So, yeah. This is Collat's conjecture. It's an example, but here, this is me going middle out. This is, to understand Collat's, really, gosh darn. I don't know what's up with this right now. Really, in the middle, I'm trying to teach multiplication. On the left, I need to grab a little bit about functions. But on the right, I'm trying to find this application of Collat's conjecture. And this was all in context of the topic of that video, which was multiplication. But I found and I taught just enough of functions in order to understand and be able to tell people about this really cool, interesting fact. But we still introduce functions and notation like this. Dude, I'm about to rage quit and just give up here. I mean, normally we write them like this, but it doesn't have to be. It's like a little more concrete if you're talking about functions with concrete specific numbers. Like this machine divides numbers by 2. Okay, I'm like literally going to give up. All right, let me just read chat. I see we got 100 push-ups now. Dude, that's insane. Bro, got the glasses falling off my nose. Yeah, dude. Yeah, logic is a perfect interlude. And Lang writes the book this way, too. He's like, we've been doing our proofs intuitively, but now let's just take a microscope and try to understand a little more carefully how we're writing these proofs. I'm not going to get into vacuous truths right now, I don't think. It just goes a little... Classical logic need not be 2-valued. Boolean algebra structure. Oh, I don't know. Really? Boolean algebra can be 3-valued? What? I don't know the distinction between constructive logic before classical logic. Are you talking about constructive logic before first-order logic? Is that what you mean? That's not unusual. I mean, this book and many logic books will teach sentential logic before first-order logic. Like, you don't have the quantifiers of for all and there exist in sentential logic. But sentential logic is very constructive. But that said, even in sentential logic, you have proof by contradiction, I think. I could be wrong about that, but this is not just theoretical. This is IRL app applied. Okay, my whole iPad is crashing. Dude, we've been going for 5 hours. I think I should call it a day. This is just a signal that, like, it's time to wrap this one up. I'm going to film this privately. I'm going to film it at night when Luna's going crazy because it's almost dinner time for her. So, yeah, I'm just going to film this tonight. Yes, Earth LO. Yes, this is school-level math. We don't teach it. to school kids anymore, but we used to. We used to. Like thousands of years, Euclid's Elements was the most successful math book. We're just in a blip of time in the last 100 years. It's a blip of time when we're not teaching all of math from Euclid's Elements. And Euclid's Elements was this kind of math. It was constructive, freaking axiomatic system, including things like proving that the square root of 2 is irrational. I think? No, maybe not. Maybe that's not Euclid. I don't know if that one's in Euclid, but like certainly the proof that there are infinitely many primes, that was in Euclid. We proved that in Euclid. The fact that lots of things, I don't know, dude. Tons of number theory facts, all of this proof-oriented math was the math textbook for school children for thousands of years. We're just in a blip of time where our math books have dinosaurs in them. Dude, for thousands of years, our math books had no dinosaurs. We didn't even know about dinosaurs for a long time. Like, most of the time we've been teaching math, we didn't even know dinosaurs existed. We definitely did not have calculators for most of the time that we've been teaching math. Euclid's Elements was proof-oriented math. That was math for a long time. And now people think math is about counting marbles and counting dinosaurs and stuff. And it's just not. Or like sending rockets into outer space or throwing baseballs around or something. There's more to math than that. Get some hard level math. This is very basic. The point is that this is basic. If you want to see my hard math, check out my representation theory streams. That's pure math at the graduate level. This week we're in school math, but legit, but more hardcore. Like, I don't know, my iPad is broken. I don't know what's going on, but my timbers are shivered. I did not know this was school level math. I better find a rich wife. What does that mean? What does that mean? I don't know what that means. We should teach constructive before classical. Yeah, like if you didn't know about this math, it's because people have been failing you, dude. Like school teachers, a lot of school teachers have not learned this. A lot of school teachers, I'm telling you, have not learned number theory or like abstract algebra, at least like at the graduate level. Like a lot of school teachers, you know, have not thought about that stuff in a while or have not thought that it's valuable to teach kids. It really is. It really is. I bet you to explain why we have to prove the first phase of induction. Hell yeah, going hard. Yeah, today was hardcore. I would go more, but my iPad is not working. My iPad is failing before I stop doing push-ups. I could do 10 more or 20 more. I owe you 10 right now. I could keep going. Do my brothers have a hard time adding 2 plus 2? It's not that hard, dude. Left hand and right hand, 2 on the left, 2 on the right. These are the numbers that exist in the real world, and that one is easy to count, you know? 2 and 2, 4. It's right there. But now, if your brother is studying 20th century logic, early 20th century logic, your brother might be reading 300 pages of philosophical discussion about why not just 2 plus 2 equals 4, 1 plus 1 equals 2. 300 pages. 300 pages in the early 20th century to prove the philosophical reasons why 1 plus 1 equals 2. That's not a joke. Those are smart, like some of the smartest mathematicians in the world just 100 years ago spent 300 pages trying to argue that. Now, we're not going to get that philosophical and that foundational, but it's crazy. No, I'm about to do it. I'm catching up. I just caught up on chat. Yeah, Locke, I will add that in, like vacuous truths, at some point, but right now it's just not the time yet in my design of this course. Here, it doesn't need to be this far, but I wanted to I don't know. My iPad is frozen, so here's my classical guitar videos, y'all. Like you can, if you like classical guitar, if you like the music. Oh shit! Why has it been muted? Why has it been muted this whole time? Has it been muted this whole stream? Streaming is hard. I'll figure this out someday. Like, has it been muted the whole stream today? The point is, it doesn't matter about the music. Point is, I owe you all some push-ups. So here's some push-ups. Thank you, dude. This is a record. Dude, I got those, and they didn't even feel wimpy this time. I think numbers like when I did 70 to 90, like the 20 push-ups, I owed people 20 push-ups during that set. They started getting wimpy at the end. Like the last couple were a little wimpy, but not as much as a few days ago. So doing 20 in a row that's when the wimpy ones start coming out. But just now, there was 10. We've done 100 so far today, and I'm feeling good. So I feel like I'm getting a little better at this stuff. That's great. Feels good, dude. All right, iPad's just broken. I'm done. We couldn't hear the guitar, but we could hear you talking. Yeah, I better. Nope, you are unmuted. Well, no, of course. I know that you could hear me. I've been talking back and forth with you all. I'm not that out of it right now. Like we've been having a whole ass conversation over here. What I meant was, has the guitar background music been muted this whole time? The guitar background music, I think, was muted. So anyways, my point is, if you all want to help support me as an artist and as an independent creator, there's a lot of ways that you can help. Leave a comment. Just leave a comment on the video, because people find these VODs. Like, YouTube is showing these replays to people. Seriously, like, honestly, my brain filters out the guitar now. Well, I'm going to play you a guitar song then. Don't ignore me. Don't ignore my guitar. Like, I'm so proud of my guitar. Like, dude. My point is, like, there's so many ways to support me, y'all. If there's some way that you want to support, you can join the Discord, discord.jcpractices.com. Join us there, hang out with us there, ask your math questions there. Let's build a really cool little community of people, just looking to talk about math and help each other with math problems and support each other. Similarly, join the Discord for Math with Ming. Math with Ming has a Discord. There's other math creators out here. Go follow them. In some weird way, that comes back and helps me too, because I think that all of the math streamers right now are just kind of like teaming up. Last night was a fun one at Leo's stream. I was hanging out in Leo's with Ming as well, and we were both chatting with Leo for like an hour or so. Yeah, dude, like, I just love math YouTube. Math stream YouTube is building up. So those are some ways, like, leave a comment in the comment section of this stream. Because then what I was trying to say is that YouTube shows the streams to people still, and people want me to keep those public, but they just don't. When they click the video and they take like 10 seconds to evaluate whether or not they should watch this at all, one of the signals is there a comment section? Did people enjoy this or not? Like, what's going on? What kind of community is in this thing? So all the amazing engagement happening in the chat here, somebody who's a newcomer doesn't see that. So just say thanks or something in the comment section. It's a completely free way that helps support me. there are things like buymeacoffee.com, or if you want to leave a super thanks or something, like there's just direct tips if you want to. There's channel memberships, things like that. But most importantly, like really feedback. Like if there's anything that you liked or didn't like about the stream, dude, feedback is such a gift. That's like I thrive on feedback, and it's the only way if I can know if I'm doing the right thing, because I have decision points everywhere. I keep getting these forks in the road, and I'm like, do I do this or that? And I don't really know whether I made the right choice between two options unless I get feedback. So if there are things that you all like, I appreciate hearing that. If there are things that you all don't like, I appreciate hearing that too. And certainly, check out the videos, the video series, and share it. If there's somebody who you know, who you think might like this crazy idea that math can be a hobby, mathcanbeahobby.com, here's my shareable playlist. Dude, it's so easy to say that out loud. Like, shareable playlist for the Lang Basic Maths series. Yeah, thank you. There's more I could say, but I think that that's a good place to end this. Thank you, everybody. Yeah, I did the push-ups. I've done 100 today. Maybe we should have a structure now. Like if I hit a new record, if I hit a new record of push-ups, I get off stage and we just like end it. It's like, hey, we hit a new record, time to get off stage. And then it keeps us thinking, oh, how far could it have gone if you kept going? So we hit a new record. We got 100 likes today. Let's see, tomorrow, can we get to 110? That's the new game that we'll play. There's a fun system, I think. I still have no idea how it's 300 pages, but Principia Mathematica... Oh, wait, no. Principia Logica? The 20th century Principia, not the calculus Principia. That one has 300 pages to prove 1 plus 1 equals 2. Or it might have been 1 plus 2 equals 3. But it's one of those. Very simple. Start streaming on. What is that? On both channels. I'm streaming to Twitch. Yes, I am streaming to Twitch. So Twitch is my multi-stream channel. If people want to be following me for both guitar and math content, maybe follow me on Twitch. I do both things there. Whereas YouTube, you have to be pretty one-dimensional and offer like one specific niche for people to click. If I had more energy, if it wasn't 5.5 hours, I would just start multi-streaming. Just like at the end of a math stream, Leroy, like that's a good idea. At the end of a math stream, like, okay, now we're a guitar channel. Like you can leave or rewind this video to see the math and multi-stream to the guitar channel at the same time. That would be cool. I think that's smart. Yeah, the guitar is background music when I have it up, but right now it's off, I think. Okay, let me catch up. Yeah, don't ignore the guitar. I'm sorry. I have to. I'm making 1,000 times more money here than the guitar channel. Unfortunately, I gotta prioritize. I love the math circle we have going on. Absolutely. Hey again from my ooh, who were you? K-Witch Math. When K comes back in on the circle, 1,000 times is a gross over-exaggeration, because I'm definitely not making $1,000 this month, whereas I have made $1 from guitar, so that's just hyperbole. I don't want anybody to think I'm making $1,000 this month from this channel, because that's not true. Even with a viral video. When Kay comes back in on the circle, yeah, we were talking about this earlier. We need Kay back. We really need Kay back. Have you ever heard of proof by intimidation? No, I haven't. I love that. I think I might have heard that idea once. That's like Lang. That's actually Lang, this yellow book. His book is proof by intimidation. And maybe sometimes it's part of the reason why I was so excited that he wrote this high school book. He proves by intimidation. He's just like, this is obvious. Like, the proof is obvious. Square. Like, that's just proof by intimidation, right? That is straight up what proof by intimidation is. Maybe the real math journey was to get buff. Yeah, kind of. Go through Tractatus Logico-Philosophicus. Yes. Bro. Where the fuck is it? Oh, I didn't even know I have Hal back here. Sick. I love Hal so much. I forgot. I need to reread this. I was just talking about this earlier. Anybody a fan of the beats, dude? Where is it? Oh, that's a book I've never read. Bro. Oh, wait. Oh, it would be my little philosophy corner over here, wouldn't it? Aesthetic. There it is. Wittgenstein. Yes, dude. You mean this book? Bro, you mean this book right here? You talking about some Wittgenstein? Yeah, we could read some fucking Wittgenstein here. I would love to explain to you all and lecture from Tractatus Logico-Philosophicus. This is an incredible book. So pretty. Very confusing. Very hard to read. Tiny book. The scariest books are tiny. This is a tiny book. This is one of the scariest books I own back there in that bookshelf. Dude, this is crazy. Oh, dude, this is such a pretty book. I tried reading it. The world is everything that is the case. 1.1. The world is the totality of facts, not of things. 1.2. The world is determined by the facts, and by these things being all the facts. 1.12. For the totality of facts determines both what is the case and also all that is not the case. The facts in logical space are the world. The world divides into facts. And any... Oh, dude, this book is so good. Yeah. Like, you gotta slow down. I just read way too much, way too fast. You need to fill in the details and try to follow the argument and follow the graph. So notice how these are, like, declarative sentences, and this is a mathematical, logical argument in philosophy that tries to take the approach of an axiomatic math system. But notice how one has this little sort of sub-argument, two has something, it's a different starting point. What is the case? The fact is the existence of atomic facts. And then everything below this is following argument two, like here with these indices. This book is crazy. Like, it's so good. Yeah, I don't know. Yeah, someday I will understand this. I couldn't get past like 2 pages of this book. I tried once. But yeah. Oh, so this is how philosophy looks like. Some of it? That's what some 20th century Wittgenstein looks like. That's all I'm going to say. That's what early Wittgenstein looks like, and then late Wittgenstein rejects early Wittgenstein. Dude, speaking of people who became school teachers, he became a school teacher late in life and, just wanted to just whip the kids into just freaking being badasses. I think he was a militant kind of authoritarian teacher, unfortunately, if I remember correctly. But he became a school teacher later in life after a crazy career as a philosopher and fighting in World War II and all sorts of stuff. Yeah, very inspired by Spinoza. I don't remember. Yeah, I do have it. You're Christian Wichman. Okay. Yeah, dude. Good call. I would love to, actually. Bro has it. Yeah, dude. This is not the first time something similar has happened a few times. Best proof strategy, instead of diagram chasing, it's page chasing. Oh, I don't know that one. Is the entire book just a list of axioms and theorems? Basically. Yeah. They're basically two different philosophers. You mean early and late Wittgenstein? Yeah, that's what I understand too. I understand that he's completely different late in life versus early. His late works are totally different. And this is early, I think. Um, and yes, it's just like one of the most axiomatic treatments of philosophy. Similar, also another axiomatic treatment is Descartes. We talked about this a lot earlier in the stream. Descartes took an axiomatic approach to try to prove the existence of God and the external world and other things. And that's where I think Therefore I Am comes from. And he had a very good starting point. He got to that point, and then after that, he's got some pretty silly arguments that have not held the test of time. But he, I don't know. I don't know, man. I don't. To me, it's just not the right question. I guess the right question. I have no idea. All I know is a lot of smart people have argued both ways on that one, and I don't know. Who knows? I don't know. So, anyways, that's about as philosophical as I want to get in this math channel. Thank you for watching. This was a pleasure. Please do like and subscribe and share this with people. We love silly arguments. I know, this is a philosophy stream sometimes because I study philosophy. So, thank you for hanging out with me. I can't believe that you all want to hang out and listen to me rant like this online. So if you know anybody else who wants to hear me rant, share it with them, dude. Share it. Like, JK is a good philosopher. You should listen to him. Who's JK? I hope you're not thinking of the JK I'm thinking of, because they are not a good philosopher. They can go away. JC, you mean. John Crossley. JC. John. You can just call me John. I don't know this. Krishnamurti. Yeah, absolutely. I have spent a long time studying some Eastern thought. In fact, probably the single class that changed my worldview and had the biggest impact on me in my life, more than any math class, was Intro to Asian Philosophy. And it was just a survey of all the different philosophical traditions. Starting with Confucianism, which is like not that different of a mindset shift, but then Taoism, Hinduism, Buddhism, like the philosophical mindset, and like studying Asian philosophy was one of my favorite courses. So, I took that class, and then I spent years studying Buddhism on my own. I just love it. Like, it's really, really pretty. Like, all right. I don't want to go down that. You're going to distract me. I got to get some real work done. You have an amazing personality. Thank you. I appreciate that. I've worked on it, I guess, in some ways. Thank you. All right, I got to go. Bye. I had fun. Twitch. Anybody on Twitch? Somebody asked me to solve some JEE math. No, of course. That's the one message on Twitch right now. Yo, solve JEE advanced maths. No. Philosophy is the one field that I have no idea how it even starts. Bro, you like to get nerd sniped. I keep nerd sniping you. The starting point being axioms. Philosophy is incredible. I could try to give an intro to philosophy sometime, and I'm telling you, you would like it. If you want to get hella nerd sniped into becoming an unemployed freaking degenerate loser, you should study philosophy. And, have questionable contributions to humanity. Thank you, everybody, for watching. This was really, really fun. I can't believe we went this long today. Thanks for watching. Bye.